Still nothing. This is so aggravating. Tell me if you see any changes show themselves. Okay. I don't know what in the world is going on here. This worked for 3 classes this morning, this projector for 2 of them, and now it's not. Rhodesia is here. Guess what? You're not the last of the alphabet this time. Okay, good deal. Now, I'll try this. I don't see what difference this would make, but I'll try turning it off and then coming back on again. That's what the computer science people always say. Well, turn it off and turn it back on. I may have to do that to the whole system, but the system was working just fine this morning. Feels like this is stripped, so that's not doing anything. Somehow, electronics knows when it's the first day of class, doesn't it? All right. As I was saying, I use a program when it works called Screencast-O-Matic. In fact, it's working right now. It's just you can't see it. And really, we need to have visuals because everything we do in here is visual. That seems to be even having a hard time coming up. This is really bizarre. Okay, the projector is coming on. And the communications have died. Of course, that's still flashing. I don't know whether that means it's trying. I'll try something else in a minute. Okay, so let's go back to this. Okay. That's not doing anything. Is anyone at all familiar with these boxes? That did nothing. What do you think? Reset, maybe? I don't know where the arrow keys are. Auto iris is off, whatever that is. Anyone at all familiar with this mess? Ha! Let's try that one. I don't know what that means. I'm going to say no. Okay. Okay. Let's exit. I think that says escape. Oh, menu is exit. Okay. That didn't seem to help much, did it? Okay. A few times, and this has happened before, tightening the screws makes it work, and other times loosening the screws has made it work. This time, neither seems to be doing a thing. Okay. Even though this worked perfectly fine just like it is, that didn't seem to make it notice anything. I hear, oh, that's my computer making noise. Ah! No. It did recognize some change that occurred. Okay, why can't one of you be a... Oh, there it was. Temporarily. There it is. Okay, finally. Isn't technology wonderful? Okay. All right, I'm recording all this and have been, so anyone coming in the program says, well, I don't want to be in this class. Okay. This is the course syllabus. However, it's not updated. Okay. Sorry about that. I had hoped to get it updated before today's class, but I've been trying to finish the first mini-term class, get all the grades in, but still working on that. A lot of this, it's just minor stuff that's wrong. I'll tell you what the minor stuff is. Most of it is correct. Okay? This is Physical Science 112, Physical Science 2. Right? Everybody got that right. It's a 4 credit hour course, 3 theory credit hours, and 1 lab credit hour, even though we're in lab for 2 contact hours for every 1 credit hour. That's how labs usually run. A few of them are 1 to 3. For a total of 5 contact hours, 3 credit, 2 labs, 5 contact. Except we're on a mini-term. So basically that's it per day. Okay? And we do Tuesday and Thursday. Now, we really don't do 3 credit hours. They do 50-minute hours. Yeah. And so that's why we 3 times 10 is 30, so it's 2.5 hours of class every day and 2 hours of lab every day for 4.5 hours every day. Okay. Now, there will be a few exceptions to that, not many, but I'll just tell you briefly how I run the course. Whatever we're going to do I'm doing from up here, we'll do it the first part of the course. Then, if there's a lab that day, we'll do it the last part of the course. The next part. If there's a test that day, that will be the very last thing. Okay? And the reason for that, I'll do this allotted amount, whatever I'm doing of the lecture or presentation and stuff like that at the beginning. Then if we're having a lab that day, and that's the last thing of the day, when you finish the lab, you get to go home. Okay? Otherwise, you would be doing the lab, somebody else would still be working on it, you'd have to sit around until we came back. I don't want you to have to sit around that much. Okay? Now, the reason we have the test at the very end of that, if we do a lab and then have a test, then you can leave as soon as your test is through. So you don't have to hang around and wait and have the test, in the middle or beginning, and then you have to wait for everybody else to finish, and you come back and do something else. When you finish the test, you go home. Okay? So if you finish early, whether it's lab or a test, you get to go home early. Okay? If I'm still talking, you don't get to go home early. I talk the full time. Okay? Sorry about that. No, I'm not. Okay. So the class does meet. Now, these times are wrong. This was from last fall. We actually started at 3:15 rather than 1:15, and we went till 7:45 rather than 5:45. So we get to start earlier and end earlier. Now the reason for that, the automotive students who were taking it last term, they have block schedules and they couldn't start their class. They ended their block schedule at 3, so they started this class at 3:15. And I thought some of them were going to be in this class, and they had their block scheduled till 1, so I started this class at 1:15. But then they wound up all taking it last time, and none of them left over to take it. Are any of you auto students, auto mechanics? Okay, well, I thought maybe that was wrong, but I think all 3 of the programs did it last time. So we could have started differently, but already all the rest of my schedule was wrapped around this, so I really couldn't change. This is correct. Okay, so let me go over it. Tuesday and Thursday, 1:15 to 3:45 is technically the class time. Okay, here, 1:15 to 3:15 is the class time. Technically, said it wrong. 3:15 to 1. Okay, let's start over. 1:15 to 3:45 is class time. 3:45 to 5:45 lab time. Okay. Now, the class will usually be in here, in this room. When I say usually, if it turns out that somebody has some sort of disability at some point, someone who hasn't shown up yet, or one of you breaks a leg or something and you can't get up the stairs, then we'll move downstairs wherever it needs to be, okay? And that's happened before, not someone breaking a leg, but someone being in a wheelchair, and you can't get up here from there, okay? So we'll move the class if we need to. Okay, the lab will usually be in here, but maybe in 250, well, I'm saying that wrong. Generally, it will be in 253, which is the next room right down the hall here, or 259, which is just down the hall there, or occasionally 252, which is across the hall from the lab up here. So we could be in any one of those three labs. I'm trying to think if any of our labs will be in here. I don't think so. I think we'll have all the labs in one of the lab rooms. And there's reasons for that. The one time we go to 252 is we need a long run to do something, and the tables in 253 are short, okay, and too short to do it. So that's why we do that. The one we do, 1 or 2 we do down in 259, it's just because the equipment is too heavy to bring up here. Now, all this may be changed if there's a lab already in one of those rooms. And I never know that until it gets to be time for it. Okay, so Tuesday, Thursday, same deal. Thursday, 1:15 to 3:45 class, 3:45 to 5:45 lab. Now, again, class lab, that's flexible. I do not believe in having a lab before we cover something in class. I can remember being in chemistry lab in college and physics labs in college where the professor was behind where the lab was, and we were doing things in the lab. I had absolutely no clue what we were doing because we hadn't gotten to it in class. So we're going to cover the material in class before we do it in the lab. So if that means taking a little extra class one day, then we'll do that. And if it's, usually things will pan out okay. Like all this stuff in the introduction now, this is like lab. This is not class. So we're having the lab first now, and we'll have the class later today, okay, when I finish all this mess. This part is correct, pretty much, okay? My name's still Charles Fowler. My office is 265. I don't know, some of you are new, you might not know where that is. Here we are in this corner classroom right here. And you go out the door here, hang a left, go down this half flight of stairs here, go almost to the end of the hall. Don't run into the wall, okay? Right before the wall, there's a stairwell that goes downstairs, okay? Don't go there. The office is right next to that. In between 263, which is the last classroom on the left, and the stairwell, that's my office. There's also a mechanical room right there. It's between the mechanical room and the stairwell. Just across the hall from the orientation classroom. Y'all know where that is. Okay, that's my office, 265. So if you need to go there. Now, what I just did by going back there, no one could hear me on my thing. So I was going to say this about Screencast-O-Matic. It records everything that's projected on the board and everything I say in sync. Okay? Now, when I went back there, it wasn't going to pick up my voice because the microphone's in my computer. And in fact, sometimes when I talk to the board, which I find myself doing a lot, that may not pick up very well, but hopefully you can hear it. I'm loud enough. Okay? I'm loud enough. She's laughing. Okay. Now, and the other thing, once the class is over, then it has to upload. It doesn't immediately go to YouTube. It has to upload, and that usually takes a few hours, okay? Which means this class ending at 5:45, that may be overnight before it finishes. Because I go home, if I don't get right away started uploading, then it may not be, and sometimes even the next morning before it uploads, okay? Just depends on whether I remember to plug it in or whatever. But usually by Friday. Now, tomorrow, I'm going to be on the road in the morning. I'm not going to be able to upload this. So if I don't get to do it tonight, it's probably going to be sometime over the weekend or even as late as Monday before this class uploads. Okay. But anyway, once it uploads to YouTube, then I move it into a playlist. Okay. address, you might say, for the playlist is located in Blackboard. And we'll talk about Blackboard a little bit later. Okay? So anyway, and I record every class, and I record as much of the lab as we can record. Of course, a lot of the lab, y'all are going to be taking measurements, and I can't record all your measurements. Certainly that won't be. So that'll be sort of dead time on the recording, or I actually shut the recording down and then pick it back up if there's questions or something. So anyway, that's how we'll do classes. Like I said, my name's here. There's my office I just talked about. Now, my office phone number is 929-3449. That's the one on this campus, Bessemer. Let me say this about my phone. Sometimes the voicemail works, sometimes it doesn't. I never know when it's working or not working. I don't know if someone's called and I missed the call. I never know that. So please, only call during my office hours, and I'll tell you my office hours in just a minute. They're not these, okay? I'll get this corrected as soon as I can. But only call during the office hours. If I don't answer, don't leave a message. Hang up and call back again later during office hours, okay? It doesn't do any good to leave a message because the odds are I'm not going to hear it, okay? Or if I do hear it, it may be weeks or months later. I don't know. It's just really weird. Now, my email address is cfile@lawsonstate.edu, and right now I'm pretty far behind in email as well, but I try to catch that up, usually on evenings and weekends, and you'll see why in a minute. But right now I'm pretty far behind on that. I'm trying to close out the first mini-term class. Now, on Fridays, I'm on the Birmingham campus, okay? Now, are y'all familiar with the Birmingham campus? Not at all. Anybody? Okay, some of you are. On the Birmingham campus, the Birmingham West campus, the old group of buildings is in the middle of sort of the circle there. There's the A building, which is the administration building. The B building is a long building in the back. That's the one I'm in. The end down here toward that new ACAT building and the new building they're just building there, that's one end. The other end is toward the gym, the tennis courts, and the baseball field. I'm on the end of the B building near the baseball field and tennis courts. Okay? Now, when you go in the B building from either end, you go either up half a flight or down half a flight. Go up half a flight. That's the main floor. That's the basement floor. Go up to the main floor and go to the end just before you take that first step down to go toward the baseball field. That last door on the left is Dr. Carl Pruitt's office, and that's B122. I'm in the copy room in his suite of offices, okay? It's right behind his secretary's desk, okay? So that's where you'll find me on Fridays. Here's the phone number there, 929-6409. I should be there most Saturday mornings from 8 to 12. I'll tell you those hours in a minute. However, do not leave a message on this phone. This isn't my phone. This is the phone that's in that office. But that office is used by a grants coordinator Monday through Thursday. It's her phone. So if you leave a message, it goes to her. I never hear it. And she probably has no way to get it to me. Okay? She won't know what you're talking about. Okay? So don't leave a message on this one. Don't leave one on that. Try to call only during office hours. Okay, what are my office hours? Now, these will be changed, so let me give you the new ones. On Mondays, I had a 8:30 Math 100 class. Fortunately, someone else needed it, so I gave that one away. So I'm free on Monday mornings and Wednesday mornings from 8 till 10. Okay? Then I've got a class at 10 o'clock. The next one starts at sometime later. In fact, I'm just booked the rest of the day on Mondays until 3:45. On Mondays at 3:45, I have another set of office hours, 3:45 till 6. So Mondays, 8 to 10, 3:45 till 6. 2 hours in the morning, 2 hours and 15 minutes in the afternoon. My biggest day of office hours. Okay. Tuesdays and Thursdays, by the way, I have an 8:30 class, 11 o'clock class, 10 o'clock class, 11:30 class, and then this class. Back to back to back, and then one little 30 minutes for lunch to back, okay? And then we're here until 5:45. So I'm not in the office. I'm in there 30 minutes in the morning from 8 to 8:30, and then I'm 30 minutes for lunch. I'm usually not in there a full 30 minutes either. And then another 15, 20 minutes at the end of the day. That's all I got on Tuesday and Thursday. Now Wednesdays, I have the 8 to 10 in the morning when I lost that class, thank goodness. But in the afternoon, I don't have that 3:45. I've got a physics class over on the Birmingham East Campus that goes 4:30 to 6:30, so I have to leave as soon as my 3:45 class is over here, packing up, getting ready to go to the Birmingham campus, and try to get there before 4:30. Okay? So Thursday, like I said, Tuesday and Thursday, from 8:30 till 5:45, almost solid. And then on Fridays, 8 to 12, Birmingham. Okay? That's the good one. That's the truth. That's the biggest chunk of office hours I have. And usually I'm there before 8, and most of the time I'm there after 12. But not tomorrow. Okay, did I mention this before? Okay, tomorrow I'm driving to Mobile, 4 to 5 hours to drive to Mobile, attend the meeting for 3 to 3.5 hours, and then 4 to 5 hours to drive back to Birmingham. Actually back here to Bessemer and then back to Birmingham. About 8 to 10 hours of driving for a 3 to 3.5 hour meeting. Doesn't seem very efficient to me, but they said I have to be there. Okay. So now, next Friday, I do know that I do not have my full office hours because I have an eye appointment right across the road here at the UAB West Hospital. Okay. There I have, I thought it was going to be at Callahan Hospital down near UAB, but they said no, on this Friday he's there. So I'm going to see him there next Friday, not tomorrow, but a week from tomorrow. That's at 8:15 in the morning, so I'll be here on campus early, go over there to my appointment, and then after the appointment, if I can see well enough to drive, then I'll be heading to the Birmingham West Campus. Okay, so I'll be there hopefully by 10 or shortly after 10 until 12 or later. Now here's the course description. Now here's something about this course description. It's nothing that I made up or anyone here on campus made up. This is something that was decided by a committee of two-year college people and the four-year colleges and universities in the state of Alabama, and they said if we do this, they give you credit for it. Okay? So here's the courses. And by the way, the meeting I'm going to tomorrow, that's the meeting. Okay, it's called the Statewide Articulation Committee. When we get together with the four-year schools and work out, if any of these things need to be changed, adjusted, added, deleted, whatever. Okay. So, this course provides a non-technical student with an introduction to the basic principles of chemistry and physics. Now, I can't change this. That's short, very short. We actually do physics and then chemistry. Okay? So only the last chapter will do any chemistry. Though physics and chemistry are a lot like this, so a lot of the stuff we'll be doing in physics will be very appropriate for chemistry as well. You have thermodynamics in physics, you have thermodynamics in chemistry. You have densities, you have a lot of the things, heat transfer in chemistry and physics. Same type deal. We'll be doing the physics side and then hit a little bit on the chemistry side. Laboratory is required. Now, that doesn't mean every day we'll have a lab, but pretty close to every day. We won't today. We won't cover enough material today for a lab. But that doesn't mean we won't take up the full 2.5 hours because we'll cover material so we can do the lab next time. Okay. The prerequisites and co-requisites, there are none, says as required by program. There is some math involved in this class. It's not very hard math or deep math. If you have something equivalent to Math 098, you're going to be okay. Okay? If you are completely clueless in math, we'll try to walk you through whatever you need to do. But it's not that bad. Co-requisites, none. Okay. The textbook, and 3 of you have this, I know it now. It's required text, and it's Tillery. He's the author. Now, those books I handed out, they look like I wrote them. I didn't. Tillery, Bill W. Tillery is the author. They just made that as a custom book for this course. That's why they have my name on it, so they can identify it's the one for this school. Okay? And it's only covering the 6 chapters that we covered. Huh?
I said that one was curious why your name was on here.
Yeah, well, that's the only reason. McGraw-Hill does this. They customize text for you. And since we only use 6 chapters for Physical Science 112 and something like 9 chapters, I think, for 111, there's no reason for someone who's only taking 112 to buy the whole book, and vice versa. But even if you're doing both classes, like some of you have, it's still, I think, supposed to be cheaper to buy the 2 smaller ones than to buy the big, large one. Because there's some chapters that we don't do in either course. Okay? So here's the text. Bill Tillery is the author, like I was showing. It is the 11th edition, which is down here at the bottom. It's McGraw-Hill, published in 2017, which means it's probably growing close to its lifetime. They like to turn over these books about every 3 to 4 years, but I use them as long as we can get away with them, especially since they have the customized text, and as long as we keep them in circulation, I'll use them. At some point, though, someone will keep a text or destroy the text or forget to turn it in or something, and then they don't have enough, and we have to go to the new edition. We used the previous edition for several years after the new one was out. Okay? Look, the physical science doesn't change. Very little amounts change. Little bits and pieces might. They change color, they change the photographs and that kind of stuff. But you see, the book publishers don't make any money unless they're selling new books. They don't make money on used books. So they like to change editions just so they can sell new books. Okay. Did I say that? Oh, sorry. But anyway, that's my warped view on publishers. Students are expected to bring the textbook, paper, and a pencil. Now, if you prefer ink, that's fine with me, but when I do math, I'll make a confession here, I tend to make errors. So I prefer to use pencil. You can use whatever you want to. Okay? Each meeting, because we will be working problem basically just about every time we meet. Because your tests are going to be mostly factual type stuff, but there will be a few problems on just about every test. The first test especially. Unfortunately, it has more math on it than most of the others, but every test after that, we usually have a few calculations. But we'll be doing lots of calculations in class. Okay? Calculators are permitted for the course, so if you have a calculator, bring your calculator. Okay? Because it's not a good time during a test to try to learn a new calculator, so try to bring it. Blackboard. Now, I make fun of this paragraph just about every time, but every now and then we have to use it more than I realize. All courses must use Blackboard to gain access to vital course information, such as the syllabus, handouts, PowerPoint shows, activities, assignments, announcements, and so forth. Okay? That makes it sound really important, and I guess maybe it is. I will put the syllabus on Blackboard. It's not there yet. Okay? So it's not there yet. I've got to make a few changes, like you just saw to it. Not going to put the wrong one out there. I want to put the correct one out there. Now, I don't know when I'm going to make those changes. I'm guessing Monday. I might be able to get them changed this weekend, but I don't know that for sure. I haven't figured out what the boss wants me to do this weekend yet. But anyway, I'll find out over the weekend. But the syllabus, and I think Saturday's supposed to be some pretty rough weather, so I might be inside able to work on it then. I don't know. So I'll have it out there. It's not there yet. Most of the time, if I have a handout for you, I will hand it out to you. So I won't be putting any handouts there. It says PowerPoint shows. Now, they're not there yet, but they will be. And they'll actually be there in 2 places. So let's go over Blackboard for a minute. I don't see the student side, so I don't know if this is exactly how it's set up for y'all, but I'm guessing. When you go to this course in Blackboard, you'll see a whole bunch of blue tabs over on the left-hand side. And they're split into groups, so maybe about 10 or so each, right? And that very first group seems like either the second or third one says instructor information or something. No, I think that says the course information, syllabus and stuff. That's where I'll put the syllabus. When I get it corrected, that's where it'll go. It's not there now, okay? I think the one directly under that, or very close to that, is something about instructor information. Now, I'll show you this in a little bit. That's where I'll put what I call my locator card. That shows when I'm on campus, off campus, in class, out of class, office hours, not office hours, lunch, whatever. That will all be on there. You'll see that a little later today, okay? Then just under, or No, okay. So that's in those two tabs. In the next group of tabs, there's one somewhere in there, maybe about the middle or the upper part of the middle, that says PPTs, that's PowerPoints, handouts, and more, or something like that, sort of a catch-all term. That's where just about everything else is going to go. So here's what's going to be there. All the PowerPoints will be there. They will be static PowerPoints. If you want to print them off before class, you can. Take notes on them. That's perfectly fine. Good thing to do if you want to do that. Or not. Whatever you want to do with them. They will be there in static form. So that's why I say you'll see them in two places. That's one place you'll see them in static form. Okay? The next thing I'll put there, well actually before those, I'll put your research paper assignment. There is a research paper in this course. Yay joy, all you who've been in my classes before know every class has a research paper. So there will be. And it's a pretty small thing. We'll talk about that a little bit later too. What's that?
I'm not good in research.
Okay, it's not going to be too bad. Okay. Now, the assignment for the research paper will be there. We're going to go over it today. I've got just a couple of little changes to make to it. But other than that, it'll go in. It's not there yet, but it will be. Okay? Then the PowerPoints. Now, I can't remember if there's any additional sites that I've listed. I don't think there are. But sometimes if students find the site they find helpful for the course, I'll put it in there. I can't remember if anyone's ever given me one for this course, so I don't think that's there. But then after the PowerPoints, usually, somewhere down there you'll see the link that is for the YouTube. See, when I record these, they go to YouTube. Then I put them in a playlist in YouTube. The link to that playlist will be there under.
You go to Blackboard also?
What's that?
You go to Blackboard?
You go to Blackboard, you go to the home page, and you go down to PPTs, handouts, and more, whatever it's called. That tab down there in the second grouping, and that's where you'll see the research paper assignment, the PowerPoints, and you'll see the link to the YouTube videos. And it'll say PHS112 YouTube videos. That's the name of it. Click on that, and you'll see every video that we've done. In fact, you'll see a whole bunch of videos. Here's what I do, and here's why I do it. I taught this course last fall. Okay? I recorded every class that I could and got it on there. I had taught the class before that. So what I do, today's class will be named Syllabus. Now we're going to do more than Syllabus, but that's what the title is. So when we finish today's class, I will go in and delete the syllabus from last time.
You need to get the new one on.
Okay, and the new one will be there. Now the old ones are going to be at the top. The new ones are going to be at the bottom. So you have to scroll down to get to the new ones. Okay? Now you might say, why not just go with a clean slate? Well, this has happened several times before. Not many. I'm saying 2 or 3 times. One time, the Screencast-O-Matic contract, they forgot to renew. So I came in one day to teach the class. I couldn't get Screencast-O-Matic to come up. They couldn't figure out why. And then they found out, they called Screencast-O-Matic. They said, well, you haven't sent in the payment. Okay, they forgot to send the info, or whatever they do. So we were a few days without it. Well, fortunately, I had the classes I had done the previous term recorded, so you still, the students still had something to look at. It may not have been synced exactly, but at least it was something. We've had other times when Blackboard has gone down. And when Blackboard goes down, I can't put anything on Blackboard. Okay? So those are unusual too. And a couple of times, and maybe not with this program, we've had the supercomputer go down up in Huntsville. And we've been without that. So nobody had any computers for a day or two. Now, a couple of times, this is several while back, we have had power outages. And of course, on a power outage day, I can't record anything then too. Okay? And since we're in the daylight, and as long as it's not miserably hot or cold, we can still have class even though we don't have power. Okay, so that's why I keep all of them up there. But as soon as we do something in this class that we had done the last time, I delete the old. Okay? So you'll have everything. The whole course is always out there on the YouTube video. The newest stuff at the bottom, the oldest stuff at the top. Now let's see. In Physical Science 1, the first mini term this time, my wife had outpatient surgery the first day of class. She couldn't help the schedule, I couldn't help the schedule. Outpatient surgery, someone has to be there in the waiting room or they won't do the surgery. So I had to be there that whole day. So what we did, they went to the videos for those days.
You watched it.
Huh?
You watched the video.
If they wanted to. I'm sure you did, didn't you? Of course you did. Okay. They were in that class. Okay. I won't even ask y'all. No, I'm just kidding. Okay. So that way we didn't have to take up another class doing what had already been done. Okay. So that's why I keep the old ones up there. So they will all be there on PowerPoint. So the PowerPoint shows will be there. Well, I said they're there in two places. Where's the second place? In the videos. In the YouTube videos, I use the PowerPoint. So you don't just get to look at the videos, you hear me talk about them, write on them, and all that kind of stuff. So they will be there. So they'll be there in two places. They'll be under the same tab here, but two places. One under each individual video, the other under each PowerPoint, the other in the videos. Okay. Activities. I can't think of any that I'll be posting on Blackboard in here, but I never know, okay? Assignments, like I said, the research paper assignment will be there. It's not there now. The rest of them will be through the YouTube video, because when we finish a chapter, I'll go over what you need to do to study for the test. But you'll have to listen to the video to get it. It's not going to be typed out somewhere. I don't have time for that. You'll see why in just a minute. Okay, announcements. I don't usually make many, but in the last class, it seemed like it was forever, okay? Because we had a field trip that was canceled and then rescheduled and canceled again. So every time we did, I had to do a new thing. But what happened, they changed the email for the faculty and staff here at the college, and now it's not talking with the Blackboard. So I tried to send emails through Blackboard and I couldn't. I don't know if they got it fixed yet. It sounds like not. They said the student email hadn't changed, but Blackboard is an old, clumsy, clunky system, and it doesn't adjust well to change. Just reading, and I'll tell you things you can study for your test. It's all for your benefit. It's nothing that I take up. The labs I take up, so there is that. And the test, of course. So everything else is getting ready for the test. All right, I do not like this next sentence. Failure to use Blackboard will severely damage your ability to pass the course. Now, possibly in some courses that's absolutely true. Because some instructors, I think, teach the whole course through Blackboard. You know, I don't. I like to teach a class. I like to interact with students, okay? So, to me, this would be far better if they said they won't let us change this. The proper use of Blackboard could greatly enhance your ability to do well in the course. That's a much more positive statement, I think, closer to the truth. This next statement I don't particularly like, but a couple times I've had to use it. Students should always check the Blackboard announcement page prior to coming to class. I can't think of any reason that would be true except for comma, in case the instructor has canceled class. Now, I'm not going to cancel class on you just because I don't feel like coming that day. Number one, I'm here just about every day. Number two, I've got 3 classes before this, so I'm going to be here for them. And if something major happens that I can't possibly be here, then the odds are I'm not going to have time to, this computer so I can, no. Probably not going to be able to feel like sending a Blackboard announcement. So what does happen if we had something scheduled, but there's no field trips in this class, okay? I wish there were, but there aren't. In the last class, we were supposed to have 2. One was canceled, brought back, canceled, and then finally canceled for good. The other one, we finally got to go to the last day of class, okay? So there were all sorts of announcements we had to do for that one. In this class, I can't think of many. Okay, now let's move on to professional competencies and objectives, okay? All right. The course student learning outcomes. Students will describe the nature of science, identify quantifying properties, use measurement systems, calculate densities, identify laws, principles, and models, and theories. Okay, guess what I just described? Let me get this out before I lose it. Okay, I just described chapter 1. Okay, chapter 1. Objectives and properties, quantities and procedures, blah, blah, blah. That's chapter 1. Okay, and there's where you see down here, chapter 1. We'll get to that in a minute. Students will solve problems using the basic principles of motion. Guess what, folks? That's chapter 2, motion. Okay? Students will solve problems using the basic principles of energy. Chapter 3, energy. Number 4, students will solve problems using the basic principles of heat and temperature. Heat and temperature, chapter 4. Now, we skip chapter 5, and therefore your little thin books won't even have it in there. That's wave motions and sound. I wish we had time for it, but I've taught the course several times. Usually we're pretty much right till the very end getting everything covered. So we don't have time for it, okay? Students will solve problems using basic principles of electricity. That's chapter 6, not 5, 6, okay? Students will solve problems using the basic principles of chemistry, and that we skip chapter 7 and go to chapter 8, atoms and periodic properties. I wish we had time for more. See, even if we had time for more, I would do chapter 9 rather than going back and doing 7 or 6 or 7, whatever the ones I skipped, 5 or 7, okay? Because that next chapter in chemistry is really great. Never had time to do it, so it's not even in the little thin book. Students will also write a library or internet-based paper. We'll talk about that a little bit later. And students will conduct laboratory experiments and write the results. Now, basically, most of these I'm going to take from this lab manual. But rather than make you buy it, I just make copies. Okay? So you don't have to buy the thing and then use just a few labs and then throw the thing away. And the labs you've used them and no one else could use it. So I just make copies and give to you. That's maybe half the labs. The other half are labs that I developed before I had this text, or that I found better than what I found in here, okay? So those are usually shorter. Maybe lots more measurements, but shorter, okay? Now, let's also talk about this. That's only 6 chapters. We got 8 weeks, okay? That's 16 class meetings, okay? Well, some of these chapters have just one lab assignment, so let's go over this. Chapter 1, there'll be 1 lab assignment and 1 test. Okay, chapter 1 is pretty short. We'll get started on it today, probably finish it Tuesday, possibly have the lab, the lab on Tuesday, and then probably the test on the next Thursday, 1 week from today, more than likely. Chapter 2, a much longer chapter. There's at least 3 labs in chapter 2. Okay, so we'll do lab assignments, but then at the end of the chapter we'll have a test on that. Now let me tell you a little bit about the test. Okay? The first test is going to be a bit more quantitative and fill in the blank than the others will be. The first test, the test bank that we had from the text was awful. So I adapted as many questions as I could and got a test out of it. But it's more calculations than you'll usually have on a test. What's that? There's some fill in the blanks, some make calculations, a few multiple choice. All the other tests, after that first one, are mostly multiple choice with a few problems with fill in the blank. Okay? Now, the final exam, on the other hand, is matching. So it's going to be one of the easiest tests you have. Okay? So, it's sort of the culmination of everything. So it's going to be pretty, simple test, I think. So most of the chapters, after chapter 1, will have multiple lab assignments. Like I said, chapter 2 has at least 3. Chapter 3, I think, has 2 or 3. Chapter 4 has 2 or 3. Chapter 5, I'm pretty sure, has 3. And chapter 6 has 1. I'm sorry, I said that. I mean chapter 8. Chapter 8 has 1. Chapter 6 has 3.
So each day we'll have a lab?
Yeah, more than one. There will be 1 lab here, 3 labs there, 2 or 3 here, 2 or 3 there, 3 there, 1 there. So that's going to be quite a few labs. Almost every class will be a lab. Not today. This is the lab part for the day. But from now on, just about every class will have a lab. There may be one or two that we don't have a lab. We haven't finished enough material to do the lab. The research paper, we'll talk about that later, and I've mentioned the comprehensive final exam. Okay. Now, how will I evaluate you or assess how you've done in the class? And they always put this sentence in here, which is, to me, is redundant, but a research paper is required for the course, not optional, required. Okay? I will talk about it a little bit later. It will count as a test, and that test cannot be dropped. Okay? Then you have a test at the end of each of those 6 chapters. Okay? The lowest of those may be dropped if that helps your overall average. You might say, well, of course it would help. No, not necessarily. If you really blew the research paper or didn't even do it, you're going to need every test you can get to bring up a 0. Okay? Because the research paper cannot be dropped. Okay? Now, so there will be, I'll drop your lowest test score. It may be dropped if it helps your average. I only do things that improve your average, nothing that will decrease it. There will be at least 1 laboratory assignment for each chapter. Most of the chapters, more than 1. Okay, so at the end of all that, I will drop your lowest lab assignment grade if it helps your average. And usually it will, but unless you have all 25s. We'll talk about that in a minute. If you have all 25s, no reason to drop any of them. Okay. A laboratory grade will be averaged from the remaining lab assignments, so I'll drop your lowest and average the rest of them. The lab average counts as 25%. Now, where did that come from? If you think back to the course, 3 hours are theory hours, and 1 hour is a lab hour. You get 4 hours credit, 1 hour is lab, so that's 25% of your grade. Right there. Okay? So therefore, just to make things easy on me, I count each lab as a 25-point lab. So at the end, I average them together. That's some fraction of 25, usually pretty close to 25. And then I take your test, the average of the paper, the remaining test scores after I drop 1 if that helps you. The comprehensive final exam cannot be dropped, and you don't want it to. It's usually one of your best scores. I take those averages. They're all based on 100. Take 75% of that average, add it to your lab average. There's your 100 points.
So what does it come from?
It comes from your research paper, your other test scores. I drop your lowest test if it helps you, and the comprehensive exam. All those average together, that's 75%. Your lab average, that's 25%. Add them together, there's your score for the course. Okay? Pretty straightforward. Okay? And I do it all on, I do as much as I can on Blackboard. I have to export it and do some stuff on Excel, and then bring it back in and put it on. Okay? The comprehensive final exam cannot be dropped. So don't come telling me at the end of the class, I have A's on all my tests, can I exempt the final? No. Okay. Because sometimes they ask for evidence of, what do they call this, competencies. And you see your comprehensive final exam is a competency. It shows what you learned in the course, hopefully. Okay? And if I don't have that, I have to average things together. That is your competency for the course. All right. Now, recently they came through and redid all these, our template for the syllabi. Okay? And they have put in all this stuff about plagiarized assignments all over the place here. So they're there. You can read them. Plagiarized assignments will receive a 0, cannot be made up. Well, guess what? It's your labs. You're going to be doing the labs right there, okay? Now, your research paper, no, don't plagiarize that either. It's a pretty short, sweet, not a really major thing. No reason to plagiarize that, so don't. So at the end of everything, if you have 70s or higher, you get C, B, or A, okay? Those are passing scores. Now, the interesting thing about the way Lawson does things, a D is not considered passing. It's not failing, but it's not passing. It's in no man's land. If you make a D, you have to repeat the course, okay, or you don't get the transfer. Now, D's never transfer anyway, so for transfer purposes, it's no man's land to begin with. But we don't even count it as passing. It's not failing, but it's not passing. F is worse because that gives you 0 quality points, and D at least gives you 1. C gives you 2, B 3, and A is 4. That's how they get your grade point average. Now, I've got to change this. I didn't realize it last term that I let this go by. I didn't write this. I don't think any mathematician wrote this. Get this. And I'm going to change this. The instructor rounds grades upward. Now, that's what it says. I.e., in the student's favor, never downwards. Notice how someone wrote this, okay? I think I know who, but I won't say any names because I don't know for sure. For example, a 79.5% would be rounded up to an 80, a B. But a 79.4 would remain a C. Now, to me, that sounds like rounding downwards, doesn't it? And that says never downwards. So I don't know who wrote, I think I know, but I don't know for certain who wrote this. Not a mathematician. So when I rewrite this, I thought I had done it last time. I ultimately didn't get it done. I'll do it this way. The instructor rounds grades normally. I'll leave out this and say then this. For example, 79.5 rounded up to an 80%. A B, the 79.4 would round down to a 79. That's normal. Okay, that's how you round. Okay, now I'm dropping your lowest lab score. I'm dropping your lowest test score if they help you. So therefore, I'm doing everything to boost your grade. If that still doesn't get you up there, sorry, that's all I can do. And actually, the research paper should be a boost to your grade, and the final exam should be a boost to your grade. So I'm doing all I can, and most of the time, people don't have problems doing well. The only reason they don't is not doing the labs, not studying for the test. So let me do a little time out here and talk about the test. Every test you take in here, including the final exam, which you probably won't need it, but every test you take in here, you can bring with you a formula and equation sheet. Anything you want to write on a piece of paper, you can bring with you. Words, definitions, formulas, whatever you want to write on a piece of paper, bring with you during the test and use it during the test. I have found, now, I'll give you a little background of this in a minute, but I found that's the very best study tool ever. And here's why. When I was an undergraduate, it would be just a handful of classes I ever remember when they let us bring a formula and equation sheet. Okay? And boy, the night before that test, I was there at my desk writing down as small as I could read, everything important that I thought might be asked, and getting as much done as I could. I had to organize, my thoughts and my material and stuff to get it all in order so I could find it easily, because writing that small, it was hard to find, so I really did. And you know what? The next day when I went to take the test, I forget to look at it, because I found that organization and planning and writing and stuff, that was the best studying I ever did for a test. I'd almost forget to look at it. I'd say, oh, wait, I have that one. Yep, I got it right, and keep on going. Every now and then say, oh, what was that? Oh, there it is, because that was the best way to study. So my suggestion to you for your entire college career, whether it's here, going somewhere else, grad school or whatever, always do a formula and equation sheet. Now, if you can't use it, don't take it to the test, but always do one. It's the very best way to actively study for a test, ever. I've never found anything that works better. So always do one. So I'll let you have one. Please bring it. Okay? All right. Attendance. Okay? Since we're going to have a lab almost every day in here, if you're not here, you're missing a lab. And that could hurt you. 25% of your test, of your grade, is going to be your lab average. So if you are going to miss a lab, be sure you get with a friend. Labs are collaborative. You work together on the lab. Get with someone and make sure they get a copy of the lab for you, and maybe collect some of the data for you, go over it with you, explain to you what's going on in there. Like I said, I'll have my program in there. I'll give the instructions on that. I'll do all I can on it, but the actual taking of measurements, it's going to be done at the lab tables, and I can't record all that, of course. That wouldn't make any sense. But please get with someone, or let me know, or arrange with me afterwards to make up the lab. Okay? There is one lab we're going to do in here. We're not going to be in any of the labs. We're going to be in stairwells, running and walking stairs. Okay? That's the lab that day. And then you'll do calculations based on that. Okay? Now, it's not hard. Don't get okay. So try to be here every day. Everything that's said here, do not overestimate your ability to catch up, blah, 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 blah. Tells you what to do if you are going to have to miss a class. So I'll let you read this. This is not going to change. This is going to be there. Okay, try to be here every day. Now, I do have at least one student, and maybe more than one, who may be coming in later because they've got a conflict, but many term classes, just not that many out here, so we have arranged that they can come. They're going to have to watch the YouTube videos to catch the stuff they missed. So there will be some people coming in that basically are only going to be here almost for the lab part, so they're going to have to get all their test study done from the YouTube videos. Okay, withdrawals. I want to include that. I don't know if I can get all this on the page at once. I'm going to try to. I don't think I can. I think there's too much written here. No, it's not going to show up because of the page break. Remember, D's and F's do not count as passing the course. F is certainly failing the course. D is not passing the course. Now, if something has happened, you can't come to class, you don't understand the labs, you bomb the test, and it looks like there's no way, and I can't imagine this, but there's no way you can avoid getting a D or an F in the course. Mostly if you just can't be here. Okay. If that were the case, a withdrawal is better than a D or an F. Okay? Now they have some words in here saying, oh, but you know, it may affect your financial aid or something else. But, well, it may affect your progression in some courses. But I don't think any of you are nursing, are you? No. Okay? I don't think any of you are auto mechanics. I asked that earlier. I don't think it's really going to matter whether you know, when you finish this course or not. Okay? But a D or an F is still going to be not finishing the course. So you're going to be in just as bad a shape with a D or an F. A D or an F hurts your grade point average. A F always does. A D would hurt it. The only time it would happen if your grade point average is less than 1. And I don't think many of you would be here if your grade point is less than 1. So a D is just about always going to hurt you. So guess what? A W, a withdrawal, yes ma'am. Okay, I'll be out of class at 5:45.
I'll tell him. Okay, I'll let him know.
Okay, this is first day of a second mini term class.
I think they need a math instructor for a mini term course.
Oh, okay.
That's what he wants to talk about.
Okay. All right. I was afraid of that because it looked like they were all going to be canceled, but I guess one of them didn't wind up making it.
He says there are 2 they need an instructor for.
Oh, wow.
Yeah.
Okay, I'll try to call at the break I have between class and lab. I won't have much time, but I'll do what I can. Goodness gracious. Many terms are so much fun. Okay. They wound up canceling just about all of them. It looked like they were going to cancel them all, and then I guess they kept 1 or 2 of them. Okay. So, the point is, a D or an F is going to hurt your grade point average. A withdrawal is not going to hurt your grade point average. A D or an F is going to hurt your financial aid. The same way a withdrawal will. There's I cannot think of a reason when you would want to take a D and an F rather than a withdrawal. So by all means, if you looks like there's no way you're going to avoid a D or an F, please withdraw. Now get down when the last date to withdrawal is and be sure you do it before then. Otherwise you're going to get a D or an F. Okay. So they put a lot of words here, but I think the bottom line is a D or an F is going to hurt you worse than a withdrawal. So, withdrawal. I don't think any of you will need to, unless it's some major emergency, medical, family, you move or something like that, and then make sure you withdraw and don't just quit coming. Okay. Makeup work. Like we've just said, we're going to have a lab every time. And you've seen what my office hours are. You're going to see another example later. I don't have many. So it's going to be really hard to make up labs. Tests going to be a little bit easier because I do have little time periods that you can make up a test, but a lab, most of those are going to take fairly close to 2 hours, okay? To find that in my day that fits your schedule, it's going to be tough. Tests we can make up. I mean, you can make up a test while I'm teaching another class, okay? So that's not going to be hard to find that. So if you do have to make up a test, try to do it within a week so I can get the test back to everybody else. The first mini-term class, I'm not sure I could return anything. There was always somebody who hadn't taken some test, and I had to wait till that person did it. It was right near the end of the class before I could return anything. I was carrying around all these papers, labs and tests, and still some people still do it. So don't do that. If you're going to miss, try to make it up within a week. Whether it's a lab or a test, get it to me within a week. You always have 1 week to work on the lab, okay? A full week, okay? The test, try to get done within that week. Now, are any of you National Guard or Army Reserve or something like that? If you are and are going to be gone for 2-week, training, yes, we'll work around that. If someone gets the flu and you're going to be out for 2 weeks, we don't want you here with the flu. Do it home. As soon as you get back, try to get it done. Okay. So that's makeup work. Lateness. Okay. I'm going to try to be here every day at 1:15, but I do have my previous class ends at 12:45. I try to go down and eat as much lunch as I can get away with and then get here by 1:15. Sometimes if the phone rings just before I'm leaving or someone comes by my office, I might be a couple minutes late, but I'm going to try to be here at 1:15 every day. I'm going to be set up, hopefully ready to go, but I may not be here right at 1:15. So you try to be here too. Okay? Like I said, some people are going to be coming and going because of other conflicts, but try to be here when you can. Okay? Academic integrity. Okay? You should know this. It's on every syllabus. Please don't plagiarize. Let's just put it there. Please don't plagiarize. Okay? Please don't cheat. You're only cheating yourselves, okay? Be honest. I mean, it's not that hard of a course. It doesn't take that much study to do well in it. So don't cheat. Now, personal decorum, my goodness. Of course, we expect you to conduct yourselves and act as professionals, all this kind of stuff. I don't want to make light of this, but I'm going to make light of it. If you sleep, please don't snore, okay? If you're that tired, try to stay awake, but if you are, don't snore. Don't be bothering somebody else, okay? And I can't imagine any of you doing this. Now, I can't imagine anyone eating, but that's going to be okay too. Or drinking. Look, I'd rather have you awake than not, okay? So if you need coffee, if you need soda with caffeine, whatever, okay? But if you make a mess, you clean up the mess. Now, when we go to the labs, those are not our labs. Okay, the one down there is, but these are not. These are biology labs. Please don't mess those up. You need to clean it if you mess it. If you don't, I've got to clean it, and I want to. Okay, so please don't eat or drink in there. Okay? Now, you know about wearing inappropriate clothes and blah, blah, blah. Hats and sunglasses, I don't care, But, I guess if someone walks in, you have to take them off, okay? Whatever. Okay, course concerns. What if you have a problem with how I'm doing things or not doing things? Maybe, okay, I've already told you I'm hard of hearing, right? So, sometimes I don't hear everything that's going on in the class, especially if I'm up here running my mouth, facing the board and that kind of stuff. If someone's being disruptive and I'm not realizing it, let me know. I'll do something about it. But sometimes I won't hear that, okay? I did have a guy last term, this thing about snoring, this is why I put it in there. He did fall asleep right where Zario is sitting. And I tell you, I was hearing it, okay. I heard the other people giggling, laughing. I thought someone was operating machinery somewhere. And then I realized he was over there snoring, and I didn't have the heart to wake him up. Because my wife says I'm Mr. Somonex when I talk, so never mind. Okay. But if you have a concern, please let me know, okay? Speak with me, one-on-one, let me know what's bugging you, okay? If that doesn't work, we'll go to the department chair. Oh, that's me. Okay, no, actually, it's Dr. Wilson for this department. So we'll go there. And if that doesn't work, Dr. Pruitt. Okay, if that doesn't work, Dean Davis. We'll go as far as it takes. We'll get it fixed. Okay? So then speak to the department chair. After the department chair, we'll go to the, they call it the area dean, and then the dean. We'll go as far as it takes. We want you to be successful. I want you to be successful. Okay? You can go to the Lawson State website and see the full range of options you have there. All right. Discrimination and harassment. Let me summarize this. We don't tolerate it. We don't want it to happen here. I've been here, I'm trying to figure out how many years now. 21, 22, something like that. I've been teaching almost in this room, that long. A few times I have to go to other rooms because we outgrow this one or whatever. Okay, but I have seen almost zero discrimination or harassment. That doesn't mean it hasn't happened. They've just not done it in front of me, which is pretty smart on their part because I don't put up with it. Okay, now I included there bullying. I don't know if they mean for us to, but I included it in there. If you see or even sense or think it could be happening, let me know because we don't want it happening, not here, not now, not ever. Now, the closest I've known of it, and this is back when we were Vestal State Technical College before we merged with Lawson, and it was one of the first few years I was teaching. We taught then a course for the automotive students called Automotive Math, okay? And I was down in a bigger classroom because I had a pretty big class of automotive students back then. And there was this one kid in the class. A lot of them were very young, right out of high school. Now, maybe y'all are out of high school too, I don't know. But they were very young, and some of them very immature. Not generally, but this one kid was. I think he was here only because his dad said, you have to go to college. And, well, he didn't want to choose a major. What do you want to do? Well, auto mechanic sounds good. So he went into auto mechanic. I don't think he had any interest in that, but I don't know. But I know he wasn't failing the course, but he wasn't at all interested in anything. And what I found out later, I thought he may be really good in cars and not care about academics. That happens sometimes. But no, I found out later he wasn't good over there either. He was just killing time. And one day at lunch, he decided to walk across people's cars in the parking lot. And somebody saw him, jerked him off of there, sent him to the dean's office. Now, all I knew was he didn't come to class that next time. I didn't know the next time was next time. And then he didn't come the next day. I said, well, where's this and so? He hasn't missed it. Oh, you didn't hear? I said, no, what? He said, and they told me the story. He walked across cars in the parking lot. He was yanked off of there, taken to the dean's office. I don't know how long he was in there, but then he was escorted off campus and never seen again. Okay? He was done with. That kind of stuff is not tolerated. And I count discrimination, harassment, and bullying worse than that. Okay? That was stupidity. This is something that's so we're fair with it. We give people good hearings and all like this, but we don't want it happening here. Now, Americans with disability, like I've already said, I'm hard of hearing, so I'm pretty sensitive about disabilities. If you have any kind of disability, let us know. I'm not an expert on that. Dr. Renee Herndon is. That's what she's trained for. Mrs. Janine McCoy-Jones over on the Birmingham campus. Dr. Herndon is here on this campus most of the time. She's head of the whole on both campuses, so she's sometimes over there, but we will get you in touch with someone that you need to be in touch with. So please let people know we want you to succeed. We don't want you hindered by a disability if we can do something about it. Any questions? Okay. Now, I'll get this updated. This is from last fall, but it basically is in your academic calendar you'll find on the website. So I'll get this updated. Lots of things are different on here. There's a couple of things that you won't see. Of course, Veterans Day was last fall. It won't be now. We won't have any professional development or Thanksgiving holiday, but we do have spring break, so that'll be on here. But then the rest of this will be pretty much like, the dates will be changed, but everything else will be pretty much the same. Any questions on that? Okay. Once I get this out there on Blackboard, I'll let you know when it is, when it's ready to go, and it's out there. Then if you'll get this last page and either do it electronically, type your name and date it, and email it to me, or print it, sign it, and give it to me. Either one to let me know you've read it. So right now, before I've got these corrections made, any questions about the syllabus? How we're going to do the course? Anything else about it? Good deal. So if there are no more questions, I'll end the syllabus. Okay. Now, next thing we want to go to, probably the research paper, since we've been talking about it. Now, there's one or two little changes on here, that's all. You choose your topic. I'm not going to assign topics, you choose your topic. Within the scope of this course, that could be anything to do with physics, anything to do with chemistry, anything to do with physical science. Okay? It can be a person. It could be a theory. It could be a phenomenon that can be explained or described with science. An application. I love application problems. Now, this is not a math class, but I'm going to give a math example. I had a guy sat right back, I can't remember your name now, but sat right there, okay, in a trig class. He was a pre-forestry major. Now, we don't have many pre-forestry majors. He's actually a Jeff State student. But he lived in McCollum, okay? And he drove by here every day. Well, he was having trouble with his math classes at Jeff State. He decided to try to take them here, and he did okay. He wasn't a great, strong student, but he was okay. But I had these assignments to make. He wrote his trig paper on the use of trigonometry in forestry. And you say, did he make that up? No, he didn't. Because guess what? When a forester goes out to estimate the lumber in a stand of trees, does he climb every tree and figure out how high it is? No. He uses a sextant, and he uses trigonometry to estimate the height of that tree, the height of the usable portion of that tree. And he does that for sampling of trees, counts the trees. He's using trigonometry. Now, that's one example. Use of physics, use of chemistry. I bet you every major in here has some use for that somewhere. So an application would be a great topic. Any other such topic about which you have an interest. It may not have anything to do with your major. It may be something you're interested in. Okay? Or, now this is something I've added more recently, an internet application or demonstration. So what if there's something I'm talking about here in class? I'm trying to think of an example. Maybe in the chemistry part, when I'm talking about the periodic table and some of the arrangement of things in the periodic table, and it's all blah, blah, blah and mystery to you, but you find some YouTube video or something like that, really does a great job of describing it, you can write your paper on that demonstration or application that made it come alive to you, that made it make sense to you. You might say what it was missing from the book or even from my presentation. I'm not going to be offended any that you couldn't understand, but when you got this, it made it make so much sense, and what it was that made it sense. And maybe the other sites you looked for, and they didn't make any sense either. You know? So you can easily come up with a paper on that. Okay? Now, what I'd like you to do either today or next week, get it done today or next week, write your name on a piece of paper. Okay? That's pretty easy, right? Now, then write the topic that you at least are thinking about right now. Now, if you go into it and find out it's too broad a topic or too narrow a topic or a topic I'm really not that interested in, yeah, you can always change it. But write down on a piece of paper your name and the topic you're thinking of writing on and give it to me today or sometime next week. Now, since that's not much to write on a piece of paper, you can also do this. This has nothing to do with the research paper. But this happens sometimes, just like she came in the door to ask me to call Dr. Pruitt. Okay? Sometimes I can knock on the door and it'll be one of the administrators. And they'll say, "This and so's in your class. You have a good phone number for her. The ones in the system aren't getting through." And I know they don't get through, because when we've canceled classes before, I try to call students when we cancel the class, and not half the time, but very frequently, the number in the system doesn't work, okay? Either they changed cell phones or something, or they moved or something, but didn't update the system. So periodically that happens. It doesn't happen often. It hasn't happened recently, but sometimes it does. So if you want to include your very best phone number, you can. I'm not going to give it to any other student, any other person, except someone here at the college who desperately needs it for your benefit, okay? Now, I'm guessing that very best phone number is going to be your cell phone, right? Okay. If there's a chance that that cell phone could be left at home, or run over by a car, or the battery died, or you changed service since the last time, or anything else like that, your sister got yours and you got hers, or something like that, if there's that chance that it could happen, if you want to leave a next best number, like Mama's landline, okay, that's not going to be changed, you can leave that if you want to. Or, I'm just making a guess here, most classes, I have at least one or more students who work. And if it may be that you're going to be at work when they're desperately trying to get in touch with you, and that's why they can't get in touch with you, if you want to leave me your work number, if you can receive phone calls at work. Some jobs don't want you using your cell phone at work, okay? But if you can receive a phone call at work and they need to get in touch with you, that's where you're going to be. You can give me that number. I won't need any more than 3 numbers. I don't need any numbers. But if you want to give me 0, 1, 2, or up to 3 numbers, just indicate which one it is. And that way, if I do need it, I can give it to that person. The odds are I'm not ever going to use it. It may be at the end of the term, if you're missing your research paper, I might call and say, where's my research paper? But, you know, that would be about it. But I'm usually not going to do that either. I'm going to probably email you or something like that. Okay. So, if you want to write that down on the same piece of paper, you can. Now, what you'll need to do once you've chosen your topic, find at least one, 2 or more or better, at least one outside source for your paper. That means outside the book. This book is not a source for your paper. This book is a source for ideas for your paper. Every chapter has at least one person they focus on in there. They talk about, you know. You can say, hey, he sounds interesting, she sounds interesting, and write the paper on them if you're doing on a person, or a theory, or something else. So you can get ideas from the paper. This can't be your source. You need to go outside. Okay, what is an outside source? It could be from any other book, journal, articles, newspaper, magazine, any such material that you can find in the library. Okay, this library, any library. Okay, 1 or 2 sources from outside the book. Now here, I hesitate, but I do it. Or others, such material, or any legitimate source found on the internet. There's a problem, folks. If I had to describe something that's been invented or developed during my lifetime that I think is the greatest advancement to just about anything, I would have to say the internet. I don't think in 1951, yes, that's when I was born, the internet was anywhere in sight. And in my lifetime, it has come about and is absolutely phenomenal. Amazing. 2, I'm sure more than 2 really big problems. 1, at least half of the stuff on the internet is total garbage. Okay? Secondly, sometimes you don't know which half. Okay? So be very careful when you're using an internet source. If you have any doubt about its validity, run it by me ahead of time. I'll look at it and I'll say, oh, no, that's good. Yeah, that's perfectly fine. Or, hey, I've never heard this, never heard of this. You might want to check something a bit more reliable. Okay? So be careful with that, but I will allow internet stuff, especially if it's an internet application you found out there, a YouTube video or something. Okay. The textbook is not an outside source, but it is a source of ideas. Really good source of ideas. Now, your paper is not necessarily a 5-paragraph essay type thing. I want at least 1 word process page of text. Double space, not single space. This is single space. Double space. It's easier for me to grade, easier for me to read, and you don't have to write as much. Now, what do I mean by a page of text? It means this. Some of you will choose to use some sort of header. Some will choose not to. I don't care. But if you do choose a header, because that's how you've learned to do it, and you have a big header up here and something another, whatever you have, triple space, and then you put your title, and triple space again, and then you start typing right here. Okay? Well, it's one page of text. That's going to go to the bottom of this page, and then on a second piece of paper, come down at least that far. That's a page of text. I've had some people move in margins and stuff and get a little something in the middle of a page and call that a page of text. No, it's not. It's got to be a regular thing, 1 inch, whatever it is, the standard thing, and it has to be at least 2 pieces of paper. One page of text is always going to be 2 pieces of paper. Now, some people print front and back. Yeah, that counts as two sides of the paper. Anyway, I'll put it that way. So that's all I'm looking for. At least one word process page of text. Double space. Standard pitch, that's 12 pitch or point font. I don't want any little tiny 9 point that I can't read, nor do I want 26 point that 3 words fill up a page and you say I'm through. That's not going to work either. Okay, so the font you use is up to you as long as I can read it. Don't get fancy and put it in Old English or hieroglyphics or something. If I can't read it, you're not going to get a good score, obviously. Okay? Lots of good fonts out there that are very readable. Try to keep the paper less than 2 pages. Okay? Now, that's not a requirement. It's just a thing. I don't want you feeling like I have to write a big, long, complicated thing. No. I just want you to write, get an idea, look at it, get excited about it, write it down. But if you get so excited about it, you can't stop at 2 pages, that's not going to be a problem. You lose points if it's too short. You won't necessarily lose any points if it's too long. Now let me give you the exception for that. And this hasn't happened often, but it has happened, I'm thinking maybe 3 or 4 times in the umpteen years that I've been doing this. So it hasn't happened often. I've had someone, and I swear, they think, well, I can't write a good paper, so I'll write a long paper. That doesn't work. I don't want that. Okay? Don't try to replace quality with quantity. It doesn't work. And here's why. When you turn in the paper, it's a 100-point paper. Okay? And then I start reading it. I can hear you say, now, don't read it, don't read it. No, I'm going to read it. Okay? And as I read it, if I start finding errors, you start losing points. So if it's a lousy, sloppily written, poorly proofed paper with lots of errors on it, the more pages you got, the more points you lose. Okay? Now, if it's a well-done, well-written paper, it can be long and still get a really good grade. Okay? So give me quality. If the quantity is there, that's fine. But don't go for quantity over quality. I want quality. Okay? Now, you can use any format you want to. Most of you in English class probably are learning MLA, Modern Language Association format. If that's what you like, that's what you're used to, that's what you know, fine, I don't care. A lot of science organizations use a program called APA, which stands for American Psychological Association. Early on in the publishing world, they came up with a really neat format. Everybody else said, hey, this is a good format. I think I'll use it. So a lot of people use APA. Okay? Now, the main thing, though, is be consistent with your format. Look at this. I've chosen to block my paragraphs. Fine. If you choose to block or indent, fine. But don't mix them up. I've had some papers turned in that they'll be blocked on this page, on the next page they're indented. What's going on here? You're not being consistent. Or even in the same page. Or this one will indent to here, and this will indent to there, and then you're back here, and then block. I mean, that's being inconsistent. Be consistent. Okay? I've actually had some people, just in the middle of a sentence, will change the font. What's going on with that? I don't know. That's not being consistent or careful. Okay? Spelling, grammar, sentence structure, all those errors will cost you points. I'm not an English teacher, but I do know good English because I have to do writing too. Okay? So I will do that. But guess what, folks? I bet you every one of you, your word processing package has spell check, and probably most of them have grammar check. And I swear that I have had some papers come in every term that they've never even run it through spell check or grammar check. Because there's some obvious errors there, could not have failed to be picked up by spell check or grammar check. So please do that. Use good proofreading. Now the content also matters. I'm not just grading it based on English and grammar and that kind of stuff. I'm also based on the science of it. That's what we're writing it for. So if I see some obvious errors in it, you're going to lose points there too. Now here's some pretty obvious ones. I've read an awful lot of papers on Isaac Newton. He's everybody's favorite, okay? And I've seen some papers, when they start out, they'll give the year of his birth and death. You don't have to do that, they just show you to do it. Then over on page 2, they have him dying a year later than he died on page 1. I said it wasn't that bad a paper. No. That not being consistent, okay? I've also had someone that was born in 1483. They said 1843. I know that's not true, okay? Because I know when that person lived. It wasn't then, okay? So be careful. So your content also matters. I've had so many in math classes, Pythagorean theorem papers. That's another real popular one. But I've had it given to me absolutely wrong. I know what it looks like. That's not it, okay? And other things too. Most of the things you'll choose, I'll have some knowledge about, and I'll know whether it's right or wrong, okay? The paper is due by the last day of class before the final examination. Now, this is a mini-term class. What we have is classes right up, including in finals week. The first Tuesday in finals week or the first Thursday in finals, whichever comes first in finals week, we have class that day. Then the last day is when we have our final exam. So you can turn it in to me that first day, but if you turn it in to me during finals, you're losing points. Okay? So get it to me before then. Okay? Now, that's the end. I recommend start early. That's why I want you to pick a topic now. Okay? I want you to start thinking about it now. I want you to start writing it soon, very soon. You'll never have more time than you do right now. Never. Toward the end of the course, toward the end of the period, you're going to be filled with papers and projects and homework and tests out the ears. You're not going to have time to work on it. Start working on it now. Okay? Now, that's the stick. Okay? Here's the carrot. Now, this is where I've got to make changes here. If you submit your paper during this month, the month of March, you get 2 bonus points just for submitting it in the month of March. You got a lot of March ahead of you. Okay? If you turn it in the month of April, now I've got to remember when finals is. I think finals are the
First week of May.
The which?
First week of May.
First week of May. So let me say this. If you turn it in the month of May, in the first 2 weeks of May, no. I said that wrong. This is March. Yeah, the first week of May is fine. The first 2 weeks in April, you get 1 bonus point. And the last 2 weeks in April or that first week in May. No, that's fine. If you turn it in any time in the month of April, you get 1 bonus point. If you turn it in May, you just get your score. Unless it's final exam, then you start losing points. So you can get bonus points for turning it in early. You lose points for turning it in late. Now, here's one last thing. I don't know of any other instructor that makes this requirement, but I do. When you submit your paper, please attach a single page, 1 page, from one of your sources, okay? Or if you chose a computer application, then the link from that computer application. But if you're writing a regular paper, include a page from your source. Now, if you have 3 sources, pick a source, any one source, print a page, not the whole article, just a single page from that source. Turn it in with your paper, okay? Any questions? Anything you're uncertain about for your research paper? Second? Okay. Not going to be too bad at all. Here again is my name, my email address, my telephone number. on this campus, my office is on both campuses. Okay? That will be posted on Blackboard as soon as I make those two corrections, the months. That's all I need to change on this one. Any questions before I close it out? Okay. That's gone. Okay. Let's go to the last object here. We got one more thing to do. This is my locator card. Spring 2019, my name, again, my two phone numbers, the one Monday through Thursday and the ones on Friday, my email address. I'm usually mathematics. I'm the chair of the math department, but I teach science courses as well. Now, I'm going to scroll this down so you see everything as much as you can. Okay, that's probably all I can get on. Okay. I come in every day, usually before 8. Okay? Occasionally, not often, but occasionally, I have bad traffic or something's happened at home or something that I can't get quite away on time. And maybe a couple minutes after 8 with very few minutes and not very often. Most of the time before 8 o'clock. Like this morning I was on campus 7:40, 7:50, something like that. Okay, but I'll try to be in my office by 8 o'clock, and I'm office advising all 5 days a week. Now, the first 4 days, Bessemer, so let's hit those first. 8 to 8:30 in the office every day. Okay? Now, I may be running copies or something like that. I won't necessarily be chained to the office, but I'm here on campus 8 to 8:30. And on Monday and Wednesday, like I said, I lost the math class, so I now have 8:30 until 10 open. So I'm in the office from 8 till 10, Monday and Wednesday. Okay? Let's continue with Monday and Wednesday. Then I have a calculus class. It's a 4-hour course, so it goes a bit longer. It goes up until 11:40, from 10 till 11:40. And then I try to squeeze in lunch in the next 45 minutes. I don't always make it, but I try to. Then I have Calculus 3 class that meets from 12:30. Again, it's an hour and 40-minute class, so it's 12:30 to 2:10. So then I have another little time in the office from 2:15 until 2:30. Not very long, just 15 minutes. Okay? Then I have a differential equations class that goes from 2:30 to 3:45. And then I'm in the office on Mondays from 3:45 and no, I have it right. 3:45 until 6. You can't see the 6 o'clock. I'll scroll down one more. Yeah, 6 o'clock. Okay. Now, Tuesday and Thursday are identical. In the office from 8 to 8:30. But then I have an 8:30 class, Math 112. Now this one is not in 255. We had to move down the hall, so I have to change that. This will be 209. No, 205. 205 is where we move. So I've got to change that. I did this before we had to move. Okay. Then I have 15 minutes in the office, and then, well, actually I don't. I move from that classroom to this classroom, and that takes just about all the time, those 15 minutes there. So I'm not in the office advising, but I have to put it there. Then I start my pre-calculus trig, pre-calculus algebra, pre-calculus trig. That's in this room from 10 until 11:15. Okay? Then I do go to my office to swap out books, because this is the same book for both courses. This is a different book, so I go to swap out. I'm not there 15 minutes, okay? I'm just there long enough to swap books and sometimes eat a granola bar or something. And then that class goes from 11:15 to 12:30, okay? And no, 12:45, 12:40, 11:15. No, that's not right. 11:30 to 12:45. That's right. Then I have a full 30 minutes of lunch there, and then this class starts at 1:15. Now, my first mini term did too, so that's why I have them both on here. But this one, same time, 1:15 to 3:45, and then the lab starts at 3:45, technically until 5:45. Now, I'll change this too, because I'll change those lab room numbers. This was it mostly for 111. I'll change the room numbers for 113. I mean 112, the one we're in now. and then we go till 5:45, and then I'll leave campus. Never at 6, but as soon after 6 if I can get away. Now, Wednesday is different from Monday. It starts off the same. From 8 to 10, I'm in the office. And then at 10, I've got my Cal 1 class, then a 45-minute lunch, Cal 3 class, and then a 15-minute break, differential equation. But then, as soon as I get out of differential equations, I start packing up to leave here, go to Birmingham East Campus, and then I have a physics class that meets 2 hours then from 4:30 to 6:30. So then I'll leave sometime after 6:30. So I'm not even on this campus after 3:45. I mean, not long after 3:45 anyway. Okay? Thursday is just like Tuesday. And Fridays, generally I'm on the Birmingham campus, Birmingham West campus, academic building, that's B122. And I'm there from 8. I'm usually there before 8, and I'm usually there well after 12. Officially, I'm there till 12. I put a lunch hour in here because I'm supposed to, but usually I just take a snack or something and I eat in my office. I eat in my office every day. I bring my lunch, eat in the office. I don't have time to go anywhere. So you can get me during lunch too. So I put this in, but most of the time I'm still working on whatever I'm working on. And usually it's after 12 before I get off. Not this Friday. This Friday I'm going the whole Friday, driving to Mobile, going to a meeting and driving back. Then on next Friday, I'll be here at a doctor's appointment at 8:15 to probably 9:15. Hopefully be back on Birmingham campus by 10 or sometime like that. Okay, any questions on my, and that's why I don't have many office hours. Monday, Wednesday morning, Monday afternoon, Friday. That's about it. Okay? I'm not supposed to teach that many classes, but I wound up teaching them. Sorry. Okay. And that just shows 6:30 off campus on Wednesday evening. Though I'm never going by 6:30, usually at 6:45 or close to 7 o'clock. Okay, that's that. Now there's one other thing we have to do that is administrative before we start talking about physical science. And that's safety. I don't have a video or anything else, so I need to stay close to the computer so it'll pick up what I'm saying. There's 3 areas of safety we always have to keep forefront of our minds. Can anyone think what one of those might be?
Your eyes.
Second?
Your eyes.
Okay. Yeah, certainly that, but I mean areas of safety.
Like a tornado or like a
Okay, yes, weather. Okay? And this is the time of year, folks, when we anticipate weather issues. In fact, my physical science class went to Channel 13 weather station Tuesday of this week. That was our last lab. That was the last day of class. And Jerry Tracy said at the time, it looks like Saturday could be bad. Okay? Unfortunately, it'll be on a weekend and we won't lose any classes. Right? Yay. Okay. But this is the time of year when it can happen. If we hear that siren go off, and we can hear it from here, it's a good loud siren that you can hear from here. Even I can hear it most of the time, so y'all will definitely hear it. If you hear it goes off, what do we do? What do we do in case of a weather emergency? That could be a tornado, severe thunderstorm, whatever. What do we do if we hear this alarm go off?
Leave the building.
No, we don't leave the building. That's what we do not do during a weather emergency. What we do during a weather emergency, 2 things to keep in mind. Go low, go interior. Low and interior. Now, where does that mean from here? Now, I'm leaving the thing here. Here we are in this classroom right here. To go low, what we do is go out the door here, hang a left, go down this hall, hang down the little half flight of stairs that goes right down here. Then immediately at the bottom, there's a flight of stairs. Go down one more flight. One more complete flight, you come out right in front of the restrooms on the first floor. Okay? Now, those restrooms are not a bad place to be. Because in the restrooms, they're low, they're interior, you have close wall space, you have lots of corners. That's where the greatest strength of a room is. In the corners where you have 2 walls perpendicular to each other. Any corner in here is going to be safer. This is not the room to be in, though, because we're exterior. Huh? The windows. You want to be away from rooms and windows. Come on in. You've probably heard this before. Okay? Now, so we go low and interior. So those restrooms are not a bad place to be. Here's the downside, besides being in a restroom for a couple of hours. That may not be out of the field. But the other thing, if we do lose power, and if there is a severe weather situation, the odds are that we would lose power. So if we lose power, there's no emergency lighting in the restroom. So I'm not sure I want to be in a dark restroom for a couple of hours. So that may lead me out somewhere else. But if you want to be, that's a safe place to be. Now, right next to the restrooms there, you go down about 2 more steps there, and there is a dean's office, the academic dean's office. If she's in there, or Dr. Pruitt's in there, or Dr. Briggs, or somebody else is in there, and they invite you in, like to come in, it's low and it's interior. Now, here's the good thing about that part of the building on the first floor. Behind this wall right here is soil. There's no building behind there. That is down below soil level. Everything else is above that. There's nothing on the other side. That's about as safe as you can be. So her office is not a bad office to be. Right next to that is a classroom. It's room 160, the one they set that classroom. It's interior, it's low, no exterior walls. The bad thing about that is a big open space. The walls are safer, the corners are safest. The middle of the room, if something were to happen up above, it could fall through. Here, not likely to happen. Okay? So stay near the walls, especially this back wall, the interior wall, that's going to be very safe. That wall's not coming down. Or if it comes down, the whole building's down. Okay? And if that's not your liking, the next room, you go through those glass doors in the hallway down there, and you're in the library. In the library area, there's a little computer room right next to that. That's a nice room because it's small, closer walls, it's interior, especially that back wall, very, very safe. Okay? The next room to that in the library is what I call the reference room. Now, it has some set shelving in it, but the back wall probably isn't going to be rocked around very much, so that's probably okay. Don't go any further in the library, because any further in the library, you're on exterior. You don't want to be exterior, you want to be low and interior. Now, I left off maybe the safest place, not necessarily safe, it's one of the best places to be, the hallway itself. Okay? Here is the advantage it has. It has no corners, so you don't have the strength of the corners. But what you do have, if power does go off, it has emergency lighting. These classrooms and offices and restrooms, no emergency lighting.
With the hallway?
The hallway does have emergency lighting. So that the walls in the hallway, not a bad place to be. About, 3, 4, or 5 years ago, something like that, we had our spring meetings for the masses. Alabama Association of Math, Alamatic, whatever that stands for, in 2-year colleges, okay? Alabama Mathematical Association in 2-year college, that's what it is. We had our spring meeting sometime in early February at University, what was the one up north? Can't think of its name now. Nice meeting rooms and stuff like this. Athens State, that's where we were, Athens State. We had driven up there, a car full of us, gone to the meeting, sat down, the reception, had some snacks and stuff. We sat down. The guy was maybe 15 minutes into the keynote presentation. The alarms went off. And we actually had to go out of that building, across the street to the next building, and that had a basement. We went down to the basement. We sat along the hallways in the basement with the lights off, but emergency lighting there, and we were there for a couple of hours. That's what you do in a weather emergency. The tornadoes passed without hitting campus, but they were sighted in the area. Okay, so there's your weather emergency. Low interior. Here's the other thing, folks. You stay together, especially when we first get down there. When I leave, I'm going to be the last one out of the room. Because if any of you have any kind of physical or other disability that you might be a little slower getting downstairs and stuff, I'm going to be with you. I'm going to be with the last person out of here, and I'm going to take my roll book. And when we get down there, I will be calling roll again. So if you have left the building and tried to make it home before the tornado, not a wise idea. If we can't find you down there, somebody has to go upstairs and risk their life and health trying to find you. So don't leave. Stay together. Once I call roll, we're all accounted for. Then if you have other friends you want to mix and mingle, you can do that. We did that too. We all went down together, and then after they were sure everybody was there, then we moved around within the basement area, along the hallways there, and met with other people, whatever, filling time. Okay. That's what you do. So there's one, weather emergency. What would be another safety issue? Some other safety issue. Any? Second?
Fire.
Fire, exactly. Okay? What if, now let's take worst case scenario first. Worst case scenario, my computer explodes, okay? And it catches those papers in my books on fire, and the desk is wooden, and it catches that on fire. What do? The fire is initiated in our classroom right here.
Fire extinguisher.
Okay, that's a very good idea. Where is the closest fire extinguisher? Does anyone know?
My lab.
Huh?
It's in my lab.
Not really that far. Right here, within 5 feet of where I'm standing, right there is the closest fire extinguisher.
Okay.
You can't get much closer than that. Okay? So one of you runs out there. I bet you some of you guys, I bet you, have always really wanted to break that glass, haven't you? I mean, it's just, wouldn't that be cool to get that thing? Yeah, I'd do that. Okay. So you get to do it then. If we really have a fire in this room, you get to break the glass, get the fire extinguisher. If you don't know how to operate it, I'll operate it and try to get it put out. Okay, so that's one thing we do. Before we go any further, let me make sure I've got you marked.
Austin.
Second,
Austin.
is that your
First
last name or first name?
First
And
name.
what? Huh?
Bale. Last name.
Bell, got it. And you go by Austin?
Yes, sir.
Okay, good. I have a good memory. It's just real short. Okay. So that's we're going over safety now. We've been over the syllabus. You can find that on the YouTube videos. We've been over the research paper instructions. That'll be on YouTube videos. And we've gone over my locator card, where I am, when I am, that kind of stuff, office hours, that. And now we're doing safety. Okay. And we haven't gotten to physical science yet, but we'll get there, except for the syllabus. That was physical science. Okay. So the first safety issue, you have to listen to this too, was weather emergency. You go low and interior. Now we're talking about fire. The worst case scenario, if the fire started in here. We've already got, somebody goes get a fire extinguisher. That's a good idea. What else do we need to do? Okay. If you're on fire, that's a good idea. But hopefully you won't be. I'll take the extinguisher to you. Okay. But
You need to
Pull the fire alarm.
pull a fire alarm. We got to notify the rest of the building that there's fire in here. Where is the closest fire alarm?
I don't know.
lock door.
Say again?
Not a door.
No, I wish it worked.
I don't know.
Okay, let me tell you something. You see this part of the building that you see here, this is second floor. All this horseshoe here, that's the oldest part of the building. Built before there were fire alarms required. Not a fire alarm anywhere on this part of the building. So to get to the closest fire alarm, what you do, you go out the door here, take a left, go down this half flight of stairs, and this corridor you see here, that goes across to the financial services, that right there. That's the newest part of this building. They don't show it here because that's first floor, not second floor. Even though it's the same level as the part of the second floor. This building is strangely put. Okay? But just inside there, you go through the two double gray doors, and you can either turn here or turn here. There's a fire extinguisher within sight, either place. There's the closest fire extinguisher. So what I recommend, one person's getting the fire extinguisher. I say two people go to pull the fire alarm. In that case, if one person slips and falls down, still the other can get there and pull the fire alarm. Okay? Do the buddy system. Okay? So somebody pulls the fire alarm. What else do we do? Ah, very good. First thing, probably, now, here is my suggestion to you. The door I come in the building, there is posted phone numbers for the campus police. There's one for Birmingham, one for Bessemer. I bet you the door you come in, that's somewhere really close by too. Put that on your speed dial, okay, on your cell phone. I don't usually bring my cell phone to class, so I can't call it. Because I don't want it going off while I'm teaching. And I don't think you want it going off while I'm teaching. So I leave it in my office. But you probably have yours on you. You don't have an office here. So dial campus police. Now, if you don't have that on speed dial, 911 is good too. But do campus police, they'll get immediately in touch with 911. Okay? Let them know. So that's almost first thing. Fire extinguisher is simultaneous with that, and getting the fire alarm pulled is simultaneous with that. Once we go to those three things, and y'all hit them right on the money this time, what do the rest of us do?
Evacuate the area.
Say again?
Evacuate the area.
Okay, absolutely. Now, how do we do that? Very similar to how we did before. We go out the door here, hang a left, go down that half flight of stairs, hang an immediate left, go down one more flight, but this time we go out of the building. For a weather emergency, you go low and interior. For an inside emergency, you go out. Now, this may not be fire. It could be a chemical spill or something else. For instance, if the fire doesn't initiate in here and we hear the fire alarm goes off, this is what we're doing. We're going out of the building. Go down this half flight of stairs, down one more flight, and then head straight out of the building. Now, where do we go? We used to go 75 feet straight out, away from the building. Okay? Because if there is a fire and it turns into an explosion and it blows the glass out, you don't want to be close to the building. You want to be far from the building. Now they tell us this. Here's our building right here. This is the A building. We're in this classroom right here. They want us to go to that parking lot right down there. We used to go to the grassy area in here. Now they have us going to the parking lot. So we go right down to the parking lot between here and Ethel Hall
That's
building.
across the street.
Say again?
It's across the street. Across the street.
Not across the street, just right down here. This parking lot right there.
Oh, okay.
Okay. Now, if you stay together, again, I'm the last one out. I'm going out with the slowest, with the last student. Okay? And as we go out, I'm making sure all are gone. And we get down there, and I carry my roll book with me, and I call roll again. And if you're not there, our assumption is that you didn't take off, say, hey, fire the building, no more classes today, I'm out of here. No, we don't do that. Because if we can't account for you, somebody, myself or someone else, has to come into a burning building, risking our health and life, looking for you, assuming you're still in the building. So stay together as a class. I'll call roll. We'll get everyone accounted for. Then if you want to mix and mingle with friends, that'll be okay as long as you stay close. They'll let us know what to do. The odds are they'll say, hey, that's it for today, go home. But let's wait till we get the official word. Okay? We were supposed to have had a couple or three fire drills already. Either weather or something else has canceled them. Don't be surprised if we don't have a fire drill. Yeah. Did you have, oh, I thought you had a question. Okay. So there's our internal emergency. Fire, chemical spill, that like that. So we've hit weather, and we've hit fire or chemical, that kind of stuff. There's a third safety issue we never used to have to even think about. I never thought about it, but recently we've had to. Active shooter. What do we do if there's an active shooter? Now, guess what? Number one, if there's a pop, pop, pop that you hear, the odds are I'm hard of hearing, so I may not hear it. So if you hear something you think could be gunfire, you let me know. And then what do we do as a class?
Me turn lights off.
Okay, that's a really good idea. We're going to turn the lights off. That's one thing for sure. Okay? Anything else?
Lock the door and hide.
Say again?
Lock the doors and hide.
Okay. Now, right before we do that, let's dial 911 or campus police. Campus police are the best number. Because guess what? He may be over there in that building or somewhere else. They may not hear the pop, pop, pop we do. So let's get them notified, if not them, 911. But then you're absolutely right. Now, this is fortunate. I happen to have a key to this door. Okay? I can lock it. There's no way to lock it. You can't lock it because there's no button here to push. I have to, unfortunately, there's no keyhole here. I have to go outside and fumble around with the keys and lock the door and come back in. I don't want her pulling it too after I've locked it while I'm out there. Okay. So then I have to fumble around with the keys to get back in. So anyway, I'll lock this door. Okay. But guess what, team? We have another entrance. This goes to two offices here, and this goes to another classroom here, and there's another door. Okay. Now the bad news here is I don't have a key for that door, the outside door going in. Okay? So, do you think we ought to lock this door?
No.
There is buttons right here. Y'all can do it. But the bad news is this locks from the inside. It's open from the outside. That would do us absolutely no good. It locks us in. It doesn't lock them out. Now, it would be great if I had a deadbolt. I key to this one. I don't. This door okay, this door right here does have buttons in it. Hey, guys. This one does have a button. We want that from the outside, and it does lock from the inside. Close that door and turn off the light. Okay, y'all get this? Someone, myself or someone else, would go around there. Okay. We would close the door to the hallway coming into that classroom. If there was a classroom in there, we'd invite them to come in here. There's not, so I don't think that would be an issue. Then we close that door, locking that door.
So we're going to be in the middle of the hallway.
What's that?
So we're going to be in the middle of that doorway.
Okay, no. We close and lock that door. We can't lock that one with little buttons. And that locks from the outside, so that's good. We'll close that middle door because Steve can see in through here. He can shoot his way in.
I thought like below.
Yeah, so what we do is close that, lock that door, close this door, close this door. Okay. Then we all get back over here.
No, I'm saying.
All right, exactly. Okay, listen up. Listen up. We get over here. He can shoot through here. He can shoot maybe through here or here. He can't shoot through there. Okay, if he could, he's going to be back here shooting, and he's going to get as much blow back as we. He'll probably get injured more than we would. So, that's the safest place to be. Then we get, like you said, low and quiet. That's why I want you to call first, so there's no more phone calls. Turn those phones off ringer. I'd say turn them off vibrate. We don't want any noise coming out of this room. We're back here as quiet as we can be. Now, if it happens to be that for some reason he does think someone's in here and is going to make his way through and shoot his way through and find a way to get in here, you don't be the hero. Your lives are all ahead of you. Mine's pretty much all back here. So I'll do whatever I can. You don't be the hero, okay? No way, okay? And I get pretty angry, and he's one to have to deal with a lot of it. Okay, so I think that would be all right. I don't think it's going to happen, number one. And if it does, if we're as quiet as we can be, he has no reason to suspect to come in here. But if he did, we'll handle that differently. Okay. Then maybe drop and roll. It might be a good idea. I don't know. Okay. Now, I've been in other classrooms, like the one I teach first thing this morning, down in 205. I don't have a key to that room. The door opens outward. It doesn't open in, just like this one. There's no way you can block it from the inside. That one we're SOL, okay, if something happens there. Okay? I teach over on the Birmingham East Campus in the nursing building. Door opens outward, nothing. I mean, this is the safest room I teach in. So, and it's not bad. I think we can do pretty well with it. All right, any questions on any form of safety? Okay, you've had your safety briefing. You know what to do if we do have a fire alarm. You know where to go now. All right, any questions? Okay, It's now 3:29. At 3:45, I have to call roll again because this is counted as a two-piece class and lab. I have to enter attendance both ways. So I have to do that every day at 3:45. So if I'm in the middle of something and that happens, remind me and have me call roll. Okay, so do you want to wait till 3:45 and have a little break then, or take a break now and then let's get started now? Or no break at all, I don't care.
You gonna be here till 5:45?
I'll be here till 5:40. I'll be here till 6, but we'll have class till 5:45, yeah. Unfortunately. I don't want to cheat you out of a penny of your tuition dollars, okay?
That's fine. Cheap.
Okay. All right. So, if you don't want to break right now, let's get into, if you do, I'll be glad to take one.
When the bookstore closed?
I don't know. I guess around 5. So if you need to go, you can. We'll still be here. Okay.
So we take a break right now?
What's that? You want to take a break right now? Let's keep it less than 5 minutes if possible. Okay. Okay. I'm going to minimize. Wait, that's not what I wanted to do. Nope. That's what I wanted to do. Okay. And we'll go from current slide. No, that's not what I wanted to do. That's it. Okay. I'll pause this so we won't be recording. Go from current slide. Any questions on anything we talked about before? Okay, and like I said, even the links to the YouTube videos aren't there yet, okay, because I haven't set up Blackboard yet. And I'm not going to get it done tomorrow because I'm driving to Mobile in a meeting and driving back tomorrow. So that's not going to happen tomorrow. It might happen sometime over the weekend if I have some time to do it. Other than that, we'll just have to see. Okay. So as soon as I can, I'll get the course set up in Blackboard, and then you'll be able to get the recordings. All right. This is actually where the class begins, the course begins, and this is in your books, and several of you have them. There's a few sitting around, so if someone wants to pick up a book, I think that's Demetrius, but if he's not here, he can let someone bum it if you want to look at it while we're doing. We're starting in Chapter 1, and Chapter 1 is one of these kind of nebulous chapters they have at the front of most science books, and my first impression was, let's just skip this and get to the real physical science. But there's a few things in here that are used in the later chapters that if we didn't do it here, we'd have to go back and pick it up. And it does have a lab, which is not, let's see how to phrase that. It's the longest lab we're going to have, almost guaranteed. Most involved, has the most pieces to it. We'll probably do it next Tuesday evening, the last 2 hours, and we may not finish it in 2 hours. With this smaller class, we might be able to. Last time I taught this, I had a huge class, and we had a hard time finishing it. Maybe we'll next time. And anyway, so there were a lot of reasons to keep the class, so I wound up keeping it. It's a nebulous title, What is Science? Okay? And here is one answer, and I don't find this a very satisfying answer, but science is a way of thinking about and understanding your environment. And basically, the thinking about is the main thing that's in here. It basically is how do you think? How do you think and put together basically nature? Okay? That's the natural sciences. Other science, biological science, how do you put together biological part of nature? And by the way, the core concept is on the front page, which is page 1 in my book. I don't know what it is in the little thin book. Okay? Now, what is science again? Here are a few other answers that some people give. A search for sense, which is sort of a cute little saying, but it doesn't really say a lot. Finding order out of surroundings. That's a lot like what it was saying, thinking and understanding your environment. That's saying close to the same thing. A lot of people think of science as just tools and rules, which is really shortchanging science big time. Okay? There's a lot more to it than tools and rules, though those are important as well. So here's the overview of the chapter. We're going to first talk quantitatively about what science is. Now, some of this is quantitative, but some of it is qualitative as well. First, going to talk about objects and properties, what they are, how we look at them, how we understand them, that kind of stuff. And here's Demetrius decided to return. Good. All right. So we're just missing Zaria from the beginning. So thank you for staying, folks. I know this is a long time. Then we're going to quantify some of these properties that we were just talking about. Okay? That's where the quantification comes in. So this part is more qualifying. This is more quantifying. Then measurement systems. That's how we go about doing our quantification. We're going to talk about the standard metric units, which they use mostly in this book. They will occasionally do some things in the U.S. customary system, but mostly we're going to be using the metric units. We'll talk about the metric prefixes as part of that. Now he's leaving again. Okay. Okay. And then we will see what we can understand from measurements. Okay? So that's the quantitative description. That's more than half of the chapter. It's the first big part of the chapter. Then on the second part, this is sort of answering what is science. We'll look at the scientific method. You've probably done that in most science classes you've taken. We'll look at explanations and investigations. Then laws and principles, models and theories. That's just, a lot of that is verbiage. What's the definition of these things? How do they compare, differ, whatever? And what more do you learn? So part of it is, as I said, sort of nebulous. Part of it is pretty specific. If we didn't do this now, we'd have to be doing it in later chapters and picking up wherever it was needed. So it sort of makes more sense to do it now. So let's do the first. Objects and properties. What is an object? It's anything that you can see, touch, feel, measure, do anything with. The desk, the table, the chair, whatever. The building, okay. Things you can see, touch. Now, surely there's objects that are smaller than that. When we start talking about chemistry, and even in physics, we're going to talk about microscopic things you can't see, can't even touch them, or if you touch them, you'll not know you're touching them, okay? But that will also be an object. Now, properties. Characteristics of that. Qualities or attributes of that. The desk here, it has a length, it has a width, it has a height. Those are things that you can tell about it. It has a color. It has a constituents. It's wood, okay? You can talk about it. Those are the properties or characteristics of the object. Now, here's an unusual word I don't think I've seen anywhere else except in this book, a referent. Now, it makes sense. I understand what it's saying, but I don't hear people talk about it. This isn't reference like a reference source. That's a CE at the end, okay? This is a referent. It's the thing you refer to. That's where the referent comes from. Comparative properties and other more familiar objects. And these descriptions, I think, are very weak and lame, in fact. Sky blue and lemon yellow. That's pretty poor reference. But they could be used as that. The problem with these kinds of reference, language can be subjective, okay? A blue sky in Seattle is probably very different from a blue sky in Phoenix, Arizona, okay? Seattle is always cloud covered just about, and when they get a little speck of blue, they think that's a blue sky. Whereas in Phoenix, you hardly ever have any clouds at all, so a blue sky would be very different there. Lemon yellow, if you have colored lemons, that would be one color. The lemons that grow on someone's tree may not be quite as yellow as the ones they color. So they're just, language is subjective. It's ambiguous. Sometimes even circular, okay? So this slide isn't saying a lot, except there's problems with how we usually refer to things, okay? So we need to quantify some properties, okay? Now, rather than saying lemon yellow and sky blue, we need to have some sort of reference or units. Okay? Now, I'm going to take a dumb one, okay, that you would never use, but just to give you an example. Compare the referent unit to the property being described. Now, here's a really dumb one. Let's say we're going to describe the distance from here to Tuscaloosa. You think we ought to use inches to describe that? No, that's a really dumb idea. Millimeters, even worse, okay? That would take huge, huge numbers, and who wants to measure that many numbers? If I was talking about the length of this room, would I want to use mile as my reference? No, again, way too big of a unit for such a small space. So, comparing the reference unit to the property being described, you need to pick something that makes sense. Okay? Now, here's a dumb one. This is what I was going to say. Let's use my stapler here as my reference unit, not inches or miles. Okay? Now, would this be a decent thing to talk about the dimensions of the desk? Not too bad. Okay? So we'll use how many staplers long and deep and wide the desk is. Okay? Now, you need to follow some procedure for specifying how the comparison is done. So what I'm going to do is start at one end of the desk, line it up with my finger, and that's one staple long. Put this finger there. There's two staplers long. There's three staplers long, and go on like that. That's a reasonable way of doing it. Follow a procedure for specifying how the comparison is going to be done. And then counting how many of the standard units, staplers, it takes to measure the length of the desk. Okay, I'm not going to do all three dimensions. That would be how we do it. Okay? Now, why did I use something as dumb as that? So you wouldn't have an already preconceived idea. It's essential. Everything you measure, there's going to be a number, of course, that's what we're measuring, how many staplers the desk is, okay, long. But you need to name the reference unit. Now, I'm going to give you an example. It's not a precise example, but I have heard it in more than one situation. The event happened. I just don't know the specifics of it. And this event was, y'all are way too young to remember, the 1960s. Okay? The 1960s, we were following World War II, and by that time, Korean War. After World War II, Europe was pretty much weakened big time. They had been fighting with each other for too long, too many wars, and England, France, Germany, who had been the big powers, Italy, they either had been defeated or exhausted. So what emerged after World War II was two big superpowers. Neither had been, well, Russia had been highly involved in the war with Hitler, but the last part, okay, and the U.S., okay, we emerged as the superpowers. Now, one reason Germany had been such a powerhouse was their education system, the brilliance of their people, their scientists, their engineers. They had developed things that beat the socks off the rest of us. Their rocketry, way beyond, no one else had rockets besides Germany. We started developing them, but no one had them but Germany. Britain didn't. They were firing their rockets from Germany and blasting Britain without the cost of a pilot or anything. They were just, now they also flew sorties and bombed Britain like crazy, but they also just sent the rockets in and just were devastating Britain. How Britain held on, I don't know. They actually had started to work on atomic energy, and they were getting very close to developing the atomic bomb. Now, one good thing in our favor, it was a terrible thing for people involved with it. The Nazi mindset hated the Jews, okay? And in hating the Jews, they were hating some of the greatest minds. We benefited because there was a little old guy with wild-looking hair named, what was his name? Albert Einstein was part Jewish. He came to the U.S. Emmy Noether was part Jewish. He came to the U.S. She may have been fully Jews. I don't know. They had some, a lot of really bright people came to the U.S. before the war. And a lot of these people brought with them some of the knowledge that Germany was using to develop the atomic. And they knew. That's how we knew they were developing. So we put together teams of people to try to beat them at it, and we did. Good, bad, or indifferent, we got there first. But with the rocketry, we didn't have ways to deliver the way they did, and we were afraid they would not only get the nuclear weapons, but be able to deliver them, and that could be pretty bad too. So when World War II ended, it was really pretty sad. The Russians went in and grabbed as many of the rocket scientists as they could, and we went in and grabbed as many as we could, even though they had been fighting against them, we had been fighting against them. We knew the brilliance that was there. And that's where the Werner von Braun's and the, goodness, I can't think of all the other names. They got a bunch of good ones too. That started the space race, okay? And even though they got fewer of the scientists, they put a lot more effort into it. The Russians beat us into space. Did y'all know that? They got the first missiles up. They got the first monkey up. They got the first people up into outer space. We never know how many people they lost or something because they were doing it fast. We were trying to do it safely, but they were beating the socks off of us and largely using the German talent. But we were using the German talent as well. Well, what happened? President Kennedy at the time vowed that we were going to get to the moon first. Within a decade, he said. And we did. Just barely, but we did. Okay? And we beat them to the moon. And from then on, we've been pretty much ahead of them. Right now, pretty solidly. But why am I going through all this? Well, because early in the 60s, if or I don't know when they developed it, NASA, National Aeronautic and Space Administration. Now, it had a name before that. I don't remember what its earlier name was, but it was something fairly similar to it. NASC or something like that. But NASA was born, and NASA got what NASA wanted because we had to beat the Russians. They had been beating us too many times. Only it wasn't the Russians, it was the Soviets then. Russia was the biggest of the Soviet states, but it was the Union of Soviet Socialist Republics, USSR. Okay? So we started pouring the money into it, pouring the technology into it, pouring our efforts into it, giving NASA anything they wanted. And we came up to them, we moved ahead of them. Yay, USA. Right. So, what happened then? We got ahead. We got to the moon first. We started doing it. Then Congress changed. And Congress said, wait a minute, we're spending too much money here. We need to be more conservative on how we're spending the money. We don't need to have NASA getting a blank check every time they wanted it. So NASA, you can't have a blank check to do your next mission. You have to farm it out. We had national laboratories with a lot of skill and talent. We had major universities with a lot of skill and talent. We had lots of resources. They said, look, farm this out to other things. So NASA had to change their whole way of doing things. And they had this mission to Mars. It was one of the Mariner missions. They had already had other missions to Mars. They had gone okay. And Mars was tough because you had to leave Earth's orbit and take off into space and hit Mars at the right time when they were fairly close and do all this. It was really a complicated problem, but we had the ability to do it. So they started farming out. They broke it into chunks, and they put out what they call requests for proposals. And they put out one chunk to launch the rocket and get it into Earth orbit. Okay? Another chunk to leave Earth orbit to make its way to Mars. and another chunk to arrive at Mars and get into Mars orbit, and then start the experimentation, start the cameras, start the instrumentation, to gather the data that the whole purpose would be there, right? So sure enough, and they were limited on the budget. Up to now, blank checks. And I'm just going to make up a number. It seems like it's somewhere around, they only had a mere $6 billion to spend on this project. Or maybe it was a million, I don't know. Let's say $6 billion. Just pick a number. They had been spending way more than that on the earlier projects. So they had it. So they broke it down, estimating how much it would do. So they put out the bids. The people sent back how they were going to do it. NASA chose the best that seemed scientifically good, the best that seemed, expense-wise. They really spent a lot of time and effort doing that. So they got these 3 different entities, each in charge of each one of these tasks. They were sweating bullets, but sure enough, when it came time for the launch went perfectly. The rocket went into orbit around the Earth perfectly. Everything worked like a charm. Then, the next group took over. It's part of the thing. The transition was perfect, left Earth's orbit, and made its way that long distance. I mean, you're talking about weeks, if not months, to get from Earth to Mars. All in our solar system, it still takes a very long time. And so they got to Mars. Then the next team was going to take over, and the spacecraft came in their control or whatever, their calculations, and the spacecraft started to go into Mars orbit and turned and crashed directly into the planet in a number of minutes or seconds. Collecting a little bit of data as it crashed, sending that back, went straight to the planet. What in the world went wrong? These were good, qualified people, good groups we had studied. What happened here? You know what happened? The second group used one set of units, metric or US, I don't know which. The next group was using a next set, but the translation, some body had forgotten to put units down. They put the numbers, but not the units. So the next group assumed it was these units when it was those units. So the next was a crash, $6 billion into the planet because they forgot to put down the units. Don't make a $6 billion mistake, okay? I hope that one day you're in a position you could make a $6 billion mistake, but don't make it, especially for something as dumb as the name of the unit, okay? So please, on everything we do, be sure you put your units down. It's really, really a great practice to get into. Not that you're going to ever be in a position to make a $6 billion error, but don't, if you are in that position, be sure you do it. Nothing is ever, very few things are referred to just by number. Always a unit with it, especially when you're doing quantifying properties. You certainly have a number, but you always have to have a unit. Units are your friends, okay? Because when you're doing problems, if the units work out, there's a real good chance you're doing the problem right. If the units come out wacky, that meant you divided when you needed multiplied or something like that. So always keep up with the units, okay? Off that soapbox onto something else. So we do have 2 different measurement systems, and probably more than 2 major ones. Now they call it the English system. It used to be called the British system. Technically the English don't use it anymore. Now they do in practice, everyday Brits do, but their official units are the metric system. They don't use this one. It's mostly the US. If you look at a listing of the major industrialized powers on the planet, everybody uses metric except US, us, and a few of the smaller countries that do most of the business with us. But in fact, in reality, go over here to the GM dealership or the Ford dealership, certainly the Toyota dealership, the programs that we have here, ask what their tools are. Guess what they all are? Metric. Nobody uses English tools anymore. Why? They market to a global market. And if every other country in the world that's going to buy the cars internationally are using metric, we've got to use metric too. Okay? Go to your medical journals. Those that are strictly in the U.S., they may give birth weights in pounds and ounces, but most of them give them in kilograms, not in birth weight masses. Okay? Because anything that's done internationally, that's the standard. So the English system, and here's what's wrong. I mean, we're used to it. We know these measurements. They're part of our core. You know, we feel like they're part of us. But guess what? They're really hard to work with. Okay? For instance, how did they come up with an inch? No one really knows for sure. One English king said it's 3 barley corns laid end to end to end. Well, if it was a good barley harvest, they could have been a little longer. A really bad barley harvest, it may have been a little shorter, right? But some people say it's the first digit of your thumb. That's approximately an inch. Okay? But guess what? Some thumbs are different from other thumbs, you know. So it's not a very good unit. Okay? Anyone want to guess about a foot? Yeah, that's not far off from what a foot is. But that's a man's foot. A woman's foot might be a little shorter. Shaq O'Neal, well, y'all won't know who he is, but, you know, pick some real tall NBA player, a lot more than a foot, okay? Shaq O'Neal has the back pain. Yeah, never mind, okay. What's that?
I think everybody knows who he is.
Okay, I thought so too. Okay, I like to just emphasize how old I am sometimes. Okay. So many units are based on the body parts. In fact, a yard, some king said, it's the distance from your nose to the tip of your finger. Say again? Yeah. And we talked about football, and we still measure that. But when we play soccer, we can't use how many yards. You have to use how many meters, because that's an international sport. Okay? So things there are changing. I remember before the 96 Olympics, we had a soccer, y'all don't remember that, do you? Y'all were born then. Yes, exactly, okay. But we had one of the preliminary rounds in the Olympics were played at Legion Field. They had to reline the field in metric units rather than in yards, okay? Now, a yard, though, was this length. Now, y'all wouldn't remember this either, but if any of you ever went to a fabric store, or actually the old hardware stores had fabric in them at the time, and the little old ladies who measured you said you wanted 3 yards of broadcloth or whatever, how did they do it? 1, 2, 3, and then a little more in case their arms were short. You know, that's how they estimated 3 yards of cloth. Now they have the tables with exactly the measurements. So it's done a little bit better, but that's how they did it, because that's approximately a yard from center to out there. That's about a yard. Okay? So how many inches in a yard? How many inches in a foot? You know, right? 12. How many feet in a yard? 3. How many yards in a mile? Second.
How many yards in a mile?
Yeah. 1,760. Nice round number. So easy to remember, right? Where did we come up with these things? Called body parts or something. I don't know where they came up with them. And guess what? They had rods, they had cubits, they had furlongs, they had... Yo! Where did these come from? Okay? Now, what if we go to volumes? Okay? How many ounces in a cup? Anyone know that? How about ounces in a pound? Let's go to weight. How many ounces in a pound? You don't. 16 ounces in a pound. Not 12, like it's 12 inches in a foot, but 16 ounces in a pound. That makes sense, doesn't it? No. How many ounces in a cup? That's 8. Okay. Whoa. Okay, how many cups in a pint? Well, that's 2. How many pints in a quart? Well, that's 2. How many quarts in a gallon? Oh, that's 4. Okay. Where do these numbers come from? Where do these... The different units are not systematically related to each other. Okay? None of them are. They're wacko, really, when you think about it. We're used to them, so we're used to dealing with them, but they don't really make a lot of sense. Okay? Now, the metric system. SI. Does anyone know what that stands for? We say System International, which sounds sort of backward, doesn't it? So quite often we'll say the international system. But you see, this was developed in France, and in French, most of the time, your adjective follows the noun rather than leads the noun. So rather than international system, they say Système International, or however you say it in French. Okay? So that's the SI system. Now, we used to call it metric system. Now they call it the SI system. Okay? And there's one small reason for that. But it was established, okay, let's go back. English system. England was a pretty small country. Okay? So it was pretty easy to keep things fairly uniform. So inches, miles, yards, pounds, quart, ounces, whatever. And besides, in the English system, they had fluid ounces for capacity and weight ounces for weight. Oh, you even call them the same thing, but they are different measures, okay? We won't even go there, okay? But in France, now, you had the two powers, France and England. England and France. They fought like dogs and cats, okay? They couldn't stand each other. They once had a war that the name of the war was the 100-Year War. They were just constantly fighting each other over a 100-year period. And that wasn't the only one. They were just always fighting each other. And if the English did this, the French wanted to do the opposite. If the French did this, English didn't want anything to do with it. Any of you ever see The Chariots of Fire, the movie? Great movie, by the way, especially around Olympic time. It was a fantastic movie. But anyway, the French people said that the Olympics were being held in France, and they said, well, couldn't we ask them to do that? Old aristocratic guy said, no, we can't ask the frogs to do anything, so they even called them names, not French, but frogs. Okay, so anyway, in France, though, they had tried to have these standards. France was a much bigger country than England, and the French not only didn't get along with the English, they didn't get along with each other. The people up in Brittany really didn't like the people in Normandy, though that was right next door, so they're always trying to cheat them. The people from Normandy didn't like the people from around Paris. No one liked the people from around Paris. They didn't like the people from Bordeaux or the people from here. So all the different sections were always trying to cheat each other. So they would cheat on the measures. And it drove everybody crazy because no one could trust anybody within their own country. So, and it was under this aristocracy, the king. Anyone know what was happening around 1791? Sarah? What war? Yeah, you better believe that there was a war. What happened in the U.S. shortly before that? As in 1776, does that ring a bell? Yeah, the War of Independence. Okay, yeah, that was our, war. And shortly following that, who are some of the people who came over and supported us against the British, no less? The French, of course, because they hated the British. So Lafayette, remember him? He came over and was a real big help to Washington. So the French were supporting us. Well, the French liked the idea. In fact, we got a lot of our ideas for the American Revolution from the French philosophers. Rousseau and several of those others were really instrumental. Well, we turned around and then we inspired the French to overthrow their aristocracy, which was the king. Louis the 16th, I believe it was. Okay? Boston's head, guillotine, that kind of stuff. That was what was happening around then. So France, everything was in turmoil with the revolution going on, the French Revolution, that's what I was getting at. And so they decided, well, since we're changing this, let's change our system so people won't be cheating each other. But we can't use people's body parts or anything else to measure anything. Let's make it uniform. So what they decided to draw, how they did this, I'm not sure, not at that time. They said the distance from the North Pole to the equator in a straight line that runs through Paris, France, since it was French, okay, we're going to take that and divide that by 1/10,000,000th or something like that and call that a meter, which in French is called to measure. That's the word metre, means to measure. So that's going to be one measure. Well, a meter turned out being just a little bit, to use a body part, a little bit longer than a yard. A yard is from your nose to your fingertip. It's from this ear to the approximately. Okay? Just a little bit longer than a yard. Okay? But everything was based on that. And then from the meter, that's the unit, the length unit, they then broke it into smaller units, like tenths of a meter. That's a decimeter. We're going to get to this a little bit later. And then they broke it down. But then they went to a mass. Okay? Well, a mass, they took a meter and did 100th of a meter, which they called a centimeter. This is approximately the width of your little fingernail to give it body part. Approximately that. And 1 cubic centimeter, that would be one fingernail this way. That would be one of those little bitty sugar cubes that don't sweeten anything. You know, that size approximately. That 1 cubic centimeter of water, they say, let's call that 1 gram. And that was the basic for the mass units. Well, that's a very small amount. So the metric unit would be gram. They said we need a bigger unit than that. So they went up to kilograms. But guess what? A kilo means, anyone know? 1,000. So this is 1,000 grams. Guess what a kilometer is? 1,000 meters. And a kiloliter, 1,000 liters. The prefixes all mean the same thing, and they're all powers of 10. Not 12s and 16s and 3s and 1,760s. Nothing like that. They're all, in everything they measure, pretty much, they use the same prefixes. We'll get to those in a minute. So, length was measured in meters. Mass was measured in, not grams. They moved it up to thousands of grams, which are kilograms. Now, this book, the heavier one, that might be 1 to 2 kilograms. Now, on the street, they're called kilos, but don't go on the streets. Okay. Now, so those are kilograms. Okay. Now, the one thing that didn't get metronized, you might say, was time. Everybody used time, and it was pretty uniform. No one was cheating on time, so they kept with seconds. And how many seconds make a minute? 60. How many minutes make an hour? 60. How many hours make a day? Well, it's not 60, it's 24. Yeah. So that's, again, sort of weird. But, now we'll back off a bit there. Where did the 6s come in 60s? Those are the ancient Sumerians. Those were predated the Babylonians. Way back then. They had base 6 system. Now, where and why, I don't know. But they did. So that's where 60 degrees, 60, all these things come in 60 seconds, 60 minutes. All those things came in. So we count seconds. Now, when we're talking about things smaller than seconds, we use milliseconds, nanoseconds. We use the metric prefixes there. We just very seldom talk about kiloseconds. We just use minutes and hours. Okay. So that's strength. Now, electric current is measured in ampere. Now, huh? Yes, you talk about milliamps, microamps, yes, or you could talk about kiloamps. Not most of the time we don't, because people don't deal with that much current, but you could use those same things. But we use those in English, don't we? Yeah. Why? Because this came along, electricity came into being about the same time. So we all decided to use the metric unit for that. Okay? Kelvin would be temperature. Okay? Notice we don't say Kelvin degrees. It's Kelvin. How many K? Mole would be a chemical measurement, how much substance there is there. That's a little different from mass. It's how much substance is there. And then light intensity is candela. We're not going to deal with these very much at all. We might basically touch on this in the chemistry chapter, but we're not going to deal with that at all. All the other units derive from these. Everything else. Area would be square meters. Volume would be cubic meters. Speed would be meters per second. Velocity, meters per second, meters per second squared. Forces would be Newton, which is a kilogram meter per second squared. Everything else is based on these units. A Coulomb, which is charge, would be an amp second. volt, so everything is built on these. Okay, that's why they say that. So these are our measurement systems. Now there's some things that are bizarre about some of these. For instance, the basic unit for length in the U.S. customary system is usually considered the foot. Okay, there's the meter. The foot's pretty short. The meter's sort of long. Okay, so when you get up to square feet, that makes sense. By the way, most of these tiles here are 1 square feet. Okay, these tiles. Okay, whereas a square meter would be more like, see, these doorknobs for some reason are about a meter off the floor. Usually, most doorknobs. And since that door, maybe not that one, but this one's a little wider, would be almost a meter wide. So that would be 1 square meter. Well, that's a lot of square feet going into a square meter. So when you're dealing with square meters, you get really big areas really quickly. Okay? But we don't have an English, when we have an English unit corresponding to the gram or kilogram, but no one ever uses it. The unit for mass in the U.S. customary system is the, anyone want to make a guess? I bet you none of you have ever used it. If anyone has, it would be rare. The unit for mass in the U.S. customary, the English system, doesn't even have an abbreviation. It's a slug. Slug, S-L-U-G, like those little slimy things that eat on your plants in the garden, a slug, but that's not where it comes from. No one uses slugs, okay? Okay, but that's the only thing. We use weight. Weight is a force, okay? It's not a mass. Now, we'll talk about how we get away with it.
Right?
Second?
Weight can be a motion.
No, weight is a force, and forces produce motion. Yeah, so yeah, you're right on there. The equivalent to force, weight here, pound here, would be the Newton there, which is a kilogram meter per second squared. So a pound here is a slug foot per second squared. Whoever uses that? Nobody. We use pounds. Okay? So we'll talk about that later when we get further along. So there are some weird things between the two, but that's what we got. All right. Now let's talk about the metric units, the standard ones. I already mentioned these. The basic unit for the length is the meter. And boy, what a strange definition this is. Nobody really uses this that I know of, but this is how they define it. It's the distance light travels, not from the distance from the North Pole to the equator through Paris divided by 10 million or something like that. That's how they first defined it. Now, precisely, the distance that light travels in 299,792,485 seconds.
They divided it.
Second?
They divided.
I don't know who came up with this. They needed something very precise. That is very precise. Okay? But no one really uses that to measure length. A meter. Light travels way too fast to measure it. That's why you have so many of those happening in a second. So many per second. Okay? Now, the mass is referenced to a standard metal cylinder. Originally, it was 1 gram was a cubic centimeter of water. But water can have different temperatures and densities and things like this, so they went back to a standard metal cylinder that is kept inside a hermetically sealed glass container, inside another hermetically sealed glass container, inside a temperature and pressure control vault, inside some laboratory in, I think, the Pasteur Institute in France, Paris, France. No one uses it. They make copies of it and send it out to people. We have a copy in our, used to be called National Bureau of Standards. It's now called National Institute for Science and Technology. We have one of those standard metal cylinders similar to the one in Paris. Okay. Time, oh my, another weird one. Reference to the oscillation of a cesium atom. Yeah, everybody uses that. Yeah, go pick your cesium atom and measure its oscillation. No. But that's what it's referenced to. Okay? Charge, We'll get to that in chapter 8 in electricity. Okay? All the other properties, volume, and everything else are derived from these and those other that we talked about. These are 4. What's that?
Coulomb for charge.
Coulomb.
Coulomb.
Coulomb, exactly. And a coulomb is the basic unit for charge in one sense, in the macroscopic sense. In the microscopic sense, submicroscopic sense, it's the charge of an atom or of a proton. That's really the basic unit, fundamentally of charge. And then it takes so many of those, it's Avogadro's number of those to make, no, it's not, it's something else. No, it's Avogadro's number to make 1 coulomb. Okay. So it's an awful lot. 10 to the 23rd. It's a lot of them. Okay, so here are those basic units again in the properties, the 7 basic properties, 1, 2, 3, 4, 5, 6, 7 basic properties. And these are the basic ones with the SI basic units. Now notice of all these units, only one of them has a metric prefix, and that's because they defined the gram to be so small, they later, to make it SI, they went up to kilogram. Okay? So length, the basic unit is your meter. Your mass, the kilogram, about like the book, you know, that would be maybe a couple kilograms. Time a second, we have a good idea what that is. Electric current, that's the basic unit. To me, it's always thought it should be the coulomb, and then how many coulombs per second should be the derived unit. But they say the basic unit is the ampere, and then they so many ampere seconds, the coulomb. Seems backward. Huh? It does seem like it to me too. Always has. But this is what they use. Temperature, not degrees Fahrenheit, not degrees Celsius, but Kelvin. No degrees there. Oh, wait a minute. Why is the symbol for meter a small m, symbol for gram a small g, the k is for kilo, and symbol for second a small s, but why is ampere a capital A, Kelvin a capital K, but then you go to small again? What's going on here? Any ideas?
They don't have anything else.
No, that's close. That's close.
It's just a number.
No, that's going to come up later with the prefixes. Okay, but here is because this was named after Louis Ampere, named after somebody. This was named after somebody, but his name wasn't Kelvin. Sorry about that. It wasn't you. Sorry, but it was William Thompson.
That was not his real name, Kelvin?
No, what his title was Lord Kelvin. He was one of the few scientists who was actually, a Lord, yes, of course, Kelvin was a Lord. Okay, so he was Lord Kelvin, so they named it after his title, not his actual name. So that was still capitalized. But these others were just named after other things. Meter is from the French word to measure. Candela.
Mega.
Okay, we're going to get to that in just a couple slides, but good thought. Good thought, and that's what you were saying too, because it was bigger.
Right.
Okay, so the metric prefixes, this is where we're going to head toward this. All right, the metric prefixes simplify conversions. You don't have to remember how many ounces in a pound, how many inches in a foot. You don't have to remember that. All you have to do is remember the units, and they work for whatever you're measuring. So if you had a meter, this isn't meter, that's too short for a meter, but if you had a meter and divided it into 10, why 10? That's how many fingers and toes we have. 10 equal units, then each one of these is called a decimeter. A decimal is every 10, right?
Right.
1/10. You're right, okay? And then, if you took this decimeter, no one really uses decimeters, and took that and expanded that, and then it would be 10 centimeters. Now, that's still a little small for a centimeter, but it's getting closer, okay? Okay? So 10 centimeters makes a decimeter. But really where that comes from, centi means what? What's that called? A penny, and how much is it worth? One what? So 1 cent, exactly. This is a centi dollar. How many cents does it make the dollar?
Wait, 100.
100 pennies make a dollar, right? It's a centi dollar. This, it takes 100 centimeters to make a meter. 10 times 10 is 100. So that's a centi dollar, a centimeter. So a centipede would have about how many legs? Not really, but 100 legs. A century has how many years?
1,000.
No, that's the millennium.
Oh.
A century, 100 years, century. How many soldiers did a centurion have under his command? About 100. See, 100, centi means 100, really 100. And then you take a centimeter and blow it up. Now that's way bigger than a centimeter, okay? And you put it into 10 equal pieces, and that's a millimeter, which is 1,000th of a meter. And how many legs should a millipede have? About 1,000. We really don't, but they do. Now, just to give you a reference, okay, a dime is about 1 millimeter thick. So that's pretty thin, okay? So that's a millimeter, okay? Takes 1,000 of those to make a meter, 100 centimeters to make a meter, and yeah, it goes on from there. Okay. So what's the purpose of these? Well, if you're measuring really small things, you don't want to use a meter. Just like you said, you wouldn't use a mile to measure the length of the room. That'd be a wrong unit. You might use meters to measure the room. To measure the block here, you wouldn't want to use meter. You would probably use centimeters. Okay, and to measure the mortar gap here, you might use a centimeter, or you might use millimeters there. Or the thickness in the grooves here, that would be millimeters. Okay, so you use them what's appropriate. So it helps avoid either writing really big numbers or really small numbers. Like if you're trying to measure this room in miles, that would be 0.000000 miles or something like that. So it would be a really small number. But if you're trying to measure from here to Tuscaloosa in millimeters, you would have so many billions of them, you know, it's huge numbers. So the metric prefixes help from writing very large or small numbers. And they're all powers of 10. And the same prefix works for mass as it does for length, as it does for current, as it does for volts, as it does for anything else. Kilo, milli, whatever. Everybody got it? Okay. So, I think they're skipping the slide on the prefixes. I don't know why. Yeah. So let's go back and look at the slide in your text, those who have books. That's page 6, okay, in your text. I know not everybody has a book, but I'll try to hold this up for a little time. I can't do it forever. Okay, starting with the basic unit, you can say meter or gram or whatever you want to do, amps or whatever you're used to. Going smaller, like we said, deci is 1/10 of that, centi is 1/100th of that, milli is 1,000th of that. Now, if you're going bigger, deca is 10 of those, and that makes sort of sense too, because a decimal place is 1 unit to the left or right, okay? But a decameter, that sounds like, how many is 10 years? Decade. So that's the same thing, a hard C sound. So that would be 10 of those. So you see we're using these prefixes in other contexts. If you have 100 of them, that's a hecto. 100, hecto, 100. And 1,000 would be a kilo. Now those in that range, between milli, centi, deci, the main unit, deca, hecto, those are powers of 10, 1 power of 10 apart. Once you get past that, you go by 3 powers of 10. You don't have a 10,000, no, you go all the way to million. So you go by powers of 3. So those are the only ones you do powers of 1. Now, I've heard people come up with different ways to remember that. One was King Henry dances down Center Main. Or there's another one or two, I don't remember what they were. There's several little things you can remember those by. But really, we use centimeters a lot. And the only reason we use centimeters a lot, it goes back to the English measurement. What is that? An inch. That was a centimeter. They're approximately close to the same values, whereas none of the others are close to an inch. Okay, so That's why we use centimeters a bit, because we're used to using inches. Okay? The things we usually measure in inches, they'll measure in centimeters. But after that, you start getting bigger units. Okay? Now, I wish we had the table. So I think I'll draw the table in here. And I'll put the prefixes. I thought they were going to show it, but they don't. Okay? So this was milli. Let me get my pen set up.
-3.
Second?
-3.
Yeah, it's -3, power of -3. But that the prefix is little m, centi is little c, deci is little d. Okay? Now, if you go bigger, 10 of these would be deca. Well, there's a D used already. So what they use for deca, in this book anyway, is DA. Deca. I don't know why. I would have been tempted to do DK, but then you might confuse it with kilo, so maybe that's why. And then 100 is hecto, 100, and 1,000 is kilo. Okay. Now, those are the powers of 10. Now, I don't have room to write the bigger ones, so I'm going to write them over here. So the basic unit goes right in the middle here. That could be meters or amperes or grams or whatever. So then you have deca, hecto, kilo. That goes up to 10 to the third. Okay, let's go below 2. You have deci, centi, and milli. Okay, going smaller. Let's go 10 to the minus, the next 3 down. This is 10 to the minus 3. 10 to the minus 6 would be micro. But guess what, team? We've already used M. So what will we use now? Second? Mu. You're absolutely right. What you do now is go to the Greek alphabet and borrow their little m, which is mu. Okay? And since we've already used m here, we'll use a mu there. Now that looks sort of like a u. It's not. This is their Greek symbol for the little lowercase m, mu. Okay? And then the next below that was 10, that's 10 to the minus 3, 10 to the minus 6, 10 to the minus 9 is nano. Okay? Nano 9. That sort of makes sense. And then after, did anyone remember Mork and Mindy? I bet not. Nano, never mind. Okay. After that, you go to 10 pico. Very good. Okay. Little p. That's 10 to the minus 3, 6, 9, 12. 10 to the minus 15. Femto. Little f. Femto 15. That's sort of easy to remember. And then I think there's one below that. Atto. I've never seen anything measured in atto, but that's 10 to the minus 18. Now, when I was doing radon research for Southern Research Institute, we were doing radon as a radioactive gas, but it's in very, very small quantities. And we talked about picocuries per liter. That is how much radiation it gives off. Curie is a radiation unit, named after Marie and Pierre Curie, mostly Marie. So this would be 10 to the minus 12 curies. That's a very small amount, but because it's radioactive, you can measure it. If that was not radioactive, you never measure anything at pico levels. And we used equipment made by Femtotech that claimed they could get down to 10 to the minus 15. But I never saw anything that measured an atom. Okay, so that's going smaller. Let's go bigger. After kilo, that's 10 to the third. Then you get 10 to the 6. That's million of them, and it's mega. M-E-G-A. Oh, no, another M. What is going on here? Here we had an M, little m for milli, so we can't use that. Then we went to Greek, little m, mu, micro, mu. What are we going to use there? Well, it's a big unit, so we went to capital, and this is what you were talking about. This is where we started using capital prefixes. And since you got mega, everything else is capitalized. That's that too. 10 to the, this is 10 to the third, this is 10 to the sixth. Anyone know what 10 to the ninth is? Yes, giga. And so you use capital G for that. 10 to the ninth. 10 to the 12th? Tera. Okay? Capital T, 10 to the 15th. Now again, I've never used this one. I don't even know how you pronounce it. Peta or peta, I don't know which. That's capital P. And then 10 to the 18th, exa, that's capital E. I've never seen anything measured in that. I'm sure things can be, but I've never seen it measured in it. So once you went to capital M's, you did the capitals from there on. Not named after anyone, it's just because they're really big units and we needed to use, like you were saying before, those had been used by other things, well, those were maybe not all those. So, how I remember this, and probably some of you do too, the big ones, I can remember the first PC that I ever saw. They were bragging about it, that it had, I don't even remember now, it was something like 4 or 8 kilobytes of memory. Wow! That was impressive. For not very long, because then they went from kilobytes to having disks that held megabytes of memory. And now it's nothing to have things that hold gigabytes, and I have seen things talked about that have terabytes. Huh?
We use gigabytes today.
They use gigabytes today, and I've heard them refer to things in terabyte form. So yeah, they've gone up there. I've never seen a peta or a peta, that's why I don't know how to pronounce it, or an exo, okay? I've just never seen anything measured that high. But you can also think of hertz. You can talk about kilohertz, megahertz, gigahertz. I'm not sure if I've heard of terahertz, but I guess you could. You have, okay? And then you can also think, this is not so good, when you talk about weaponry, so many kiloton bomb, so many megaton bomb, and I think some of the hydrogen bombs are like
10,000?
Huh?
A ton.
They're talking about the same explosive power of that much of the dynamite, or TNT type stuff. So they do use that, but that's pretty destructive. I like to think of hertz and bytes and things. Those are more positive than the others. All right. So those are your metric prefixes, and that's where the capitals come in there. They're big units. So, all right. They didn't have that on the slide, but it's in your book. On page 6, table 1.2. All right. Now let's move to, I'm going to have to ask you a big favor. Don't let me run over, okay? I know y'all probably want to listen to me talk all night long, but if I get close, y'all let me know, okay? Yeah, we're not there yet, but we're getting closer. Okay, because I'll keep talking forever, as you can tell. Okay? Don't be reading too much. Okay, now, understanding from measurements, okay? Basically, what do we measure? What do we get from measurement? You get data. How long's the desk? How tall's the desk? You get numbers with units. That's your data. Now, here's something that's a little bit of a pet peeve of mine. I think most scientists go along with this. Data is a plural word. A single bit of information is a datum.
It's context, right?
Huh?
Context.
Yes. But if you say, what does this data, the data, okay, you got to get it right now.
Okay.
You'll hear people say, the data indicates this. Wrong. Or the data says this. Or the data implies this. It's the data, use a plural verb, not a singular verb. The data indicate this, not indicates like it's singular, indicate plural. The data is, no, it's the data are, okay? So that's a plural word. That's the information you get from measurement, okay? Now, you can take those data, and then look at how they relate to other data. And you can relate to them quite often with ratios. And that's what we're going to do one of the next things.
What about proportion?
Yeah, and a ratio is setting two proportions, proportion is setting two ratios equal to each other.
Yeah.
So yeah, that comes next, okay?
All right.
Okay? And then you can make generalizations from that. Now, one of the things we're going to do in the next chapter when we're talking about motion, what is involved with motion? Just give me an idea. Motion. Say again? Okay, you're absolutely right. Wow. That's 3 chapters away. Very good, though. But in the basic form, motion means you were here, you went there, right? So what did you do? You moved a distance.
Move to place to place.
Place to place, exactly. And you measure that in how far you move. That could be inches, it could be miles, it could be centimeters, it could be feet, whatever. That is a distance measurement. But if you want to get a little more sophistication in it, you not only moved there, but you took a certain amount of time to move there. So now if you do the ratio between distance and time, what do you get? Feet per second, miles per hour. What's that measure? Speed or velocity. No, distance is your meters or feet or something. Meters per second, that would be how fast you're going. That's your speed. Then you take the ratio of that to time, and you get how fast are you changing your speed. What are you doing then? The velocity is speed. If you're changing the speed, you are going faster. What pedal do you push? Accelerating. You're accelerating. Okay? Exactly. So you see, by looking at data and then combining them in different ways, especially by division, you can come up with ratios that you can make more generalizations about. We'll be doing that in the next chapter. Another ratio is called the density ratio. That's the one we're going to spend a lot of time with in this chapter. But you have many others. Pressure is a ratio. Pressure is force per unit area. What unit, U.S. customary unit, do we use to measure pressure? Anyone know? Power pressure. Measuring say again? What does PSI stand for? Pounds per square inch. Pounds is a force measurement. Square inch is an area measurement. Pound force per unit area, that's a pressure.
This is volume.
Say again? Okay, density is mass per unit volume or weight per unit volume. That's exactly it. It's a ratio of those two quantities. Force per volume, which is weight per unit volume, or mass per unit volume, which would be mass per unit volume. Okay. Now, next after that, we'll talk about symbols and equations, how we relate these. And we've just been saying the equations. We'll actually write them down and use symbols for the various things. And then we'll talk about how to solve problems more easily. This is the context of what we're going to do under this subtopic. This is 1.6, Understandings of Measurement, and we're going to look at each of these topics separately. So let's first look at data. Look at some of the data we can collect. Okay, basic unit for length. The metric system is meter. The U.S. customary system or British system or English system would be foot. It doesn't matter what it is. It's how long something is, how far something is. That's your length measurement. Okay? Now you can take an object like this. This happens to be a cube. Now what does it mean to be a cube? There's two characteristics of a cube, maybe more, but two main. Say again? Okay, actually it's six. Okay? You have a square here, a square there, a square on the back side, a square on this side, a square on the bottom, and a square on the top. So basically, what's a square? What makes a square? Second? Four sides. What has to be true about it to be a square? Equal lengths and equal angles. Both of those have to be true. So the same thing with the cube. Every side is the same length. Now that looks shorter, but it really, because this is a three-dimensional picture on a two-dimensional board, it's hard to do. Okay? Every length is the same. And every angle is the same too. They're all right angles. Okay? So, y'all have hit several of the key things here already. So the area of one face, if the length of one side here, the cube with an edge length of S, just to give it a symbol, S is the whatever that is measured in, inches, feet, yards, or whatever, its length is S. Okay? So what would be the area of this square then, as you said? That's the square. It would be S times S. S times S, that would be S squared. right?
Yes.
Okay. Now, how many sides did you say it had?
6.
6 sides. So the total area of the whole cube would be 6 of those little a's, which would be 6 times s squared. So there is another thing you can get. The data is just one measurement here, okay, or datum, okay, and then to get the area, that's you do an analysis or an operation on that, and then to get the whole cube, multiply it by 6. But what would be the volume of this cube? Length times width times height. Exactly. So that would be s times s times s. Well, that's just simply s cubed. All right, exactly. All right, so here is how we put the data together in different ways to get different quantities. Area of one face, area of the whole cube, or volume of the whole cube. Okay? So measurement information is used to describe the objects. How many cubic inches is that? How many cubic feet is that? How many cubic yards is that? How many cubic miles or meters is that? Whatever. You're describing that. And it's, each face is how many square centimeters or whatever. The conditions, you might be talking about the temperature of it. You might be talking about, you can use other things. You measure the data, getting you the information to describe the cube. You might be measuring an event. How long has that cube been there? Okay, that would be a time measurement. Or how has that cube changed over time? Has it shrunk? Has it increased? Has it gotten hotter and swelled? Has it cooled and swelled down? Did it melt some? Did it freeze? What has happened? Any changes that have happened to it? And then this example of the dimensions of a cube. Just different ways you can measure one bit of datum, one piece of information, and how much more information you can get. The area, the volume, the surface area, whatever. Okay. Now, ratios and generalizations. Let's take we'll do 3 cubes. Now we're going to inches. I said most of the book will be using metric. Here they're going to use U.S. customary or British or English, whatever you want to say. So let's take a cube that has 1 inch on the side. Okay? What would be the surface area of one face of that cube? Surface area, one face of that. That would be 1 inch by 1 inch.
1 inch.
1 square inch. The unit, when you're multiplying or dividing the numbers, you also multiply or divide the units.
Okay.
So 1 inch times 1 inch would be 1 times 1 is 1. Inch times inch is inch squared.
Okay.
And how many sides did you have?
4.
Huh?
2.
6. Remember?
Are we talking about cube?
The cube, yeah.
Okay, you had 6.
6. Okay? So multiply that 1 square inch by 6 and you get 6 square inches. But what was its volume? 1 inch by 1 inch by 1 inch deep. 1 cubic inch. Again, 1 times 1 times 1 is 1. Inch times inch is cubic inches. So what's the ratio of your area to your volume? Now this is something I don't like the way they did.
6 divided by 1.
This would be 6 divided by 1 here. That's right. And here they put just a number.
And you had to subtract the exponents.
Yes, you would subtract the exponent, so that would be inches to the -1 or per inch, which is a rather strange thing. So they're just looking at the quantity, not the dimension. I hate it they're leasing that
So
out.
you want us to, for the test, you want us to do the inches and exponents on the test?
You could if you want to, but when you're doing these ratios like this, you can leave those off.
Okay.
Because that's what they're doing here. Okay?
All right.
But when we're doing real measurements, yeah, always put the units in whatever they are.
Okay.
Now, let's go up, double the length of that individual square. So now it's a 2-inch cube. So what would be the area of one face? If this is 2 inch by 2 inch, what would that be?
4 inches.
4 square inches.
4 square inches.
You multiply the units as well. Now here's the other thing, and I like to do it, they don't do it. They just put IN. When I'm abbreviating inch, I always put IN period. Any idea why I might do that? None of the other units do I put a period after, but I do after inch. Any ideas? Because in is also a word, IN. So if that was in a sentence, you might say 1 in what?
So that's
No,
the
it's not, yeah. So if you put a period, you understand that's the unit inch, not the preposition
So the
in.
abbreviation of each.
Yeah, and yeah, but they don't do the others. And I always do it for the inches squared and inches cubed. I always put that period. Now that's old school. I don't think modern they do that anymore, but that was very common. Whereas foot, FT, I don't put a period after that. But inches only because that is a word. Okay. All right. So a 2-inch square would have an area of, you said it? 4 square inches, exactly. But how many sides do you have? 6, and 6 times 4 is? 24 square inches. But what is the volume of that 2-inch cube? 2 by 2 by 2 by 2 by 2 is? 8 cubic inches. Okay? So what's the ratio of that area to volume? This was 6. This is only 3. Well, let's move up to 3-inch square. 3 inch on each side of this cube. Okay? So 3 inch by 3 inch would be how much area? 3 inches by 3 inches. 9 what? Square inches, exactly. But how many do you have? 6 times 9 is? 54 square inches. That's the surface area of that cube. What is the volume of that cube? 3 inches by 3 inches by 3. That would be 27 cubic inches. What's this ratio? Look at that. As the cube's getting bigger, the area to volume ratio is actually getting smaller. Isn't that bizarre? Okay? But you know this is true. Okay? Now, here's, and here they did a graphic of it too. Here is a 1 inch is the light blue, 2 inches is the sort of violet, or what is that other color you call that? And then the dark blue, cobalt blue would be the 3 inches. If your area is this, that's 6 square inches, only 1 cubic inch, area to volume ratio would be 6. But then when you go to 2-inch cube, that would be the area of now 24 square inches, but the volume is increased to 8 cubic inches, so its ratio is decreased to 3, from 6 to 3. But then when you go to the 3-inch cube, the area is really ballooned to 54, but the volume is taken off to be 27, and that ratio is only 2 to 1. So as you get larger and larger cubes, you get smaller and smaller ratios. Now, what difference does this make? Well, let's go the other way, starting with big and going to small. Okay? I like to start, rather than cubes, let's do jelly. So let's have, what size you want of jelly? A cube of jelly. Second? Just name a size.
Small.
Okay, name. What dimension?
Head go.
Second?
Head go.
Not hearing so bad.
Micro.
No, not that small. Just give me a number for the size of this.
8
what?
inches.
Square inches. Okay. That's going to be a face. 8 square inches. Okay. So every face has 8 square inches. So you know the area and you know the volume, right?
Right.
Now I'm going to take a sharp knife or a hot string or something and cut through one face of that cube of jello. Going to cut it in 2. Now what have I just done? The mass of the jello is the same. The volume of the jello is the same. But by cutting through and making 2 smaller pieces, I've just increased the surface area. Now I have a face here and a face here that weren't there before. But it's the same mass, same volume, I've increased the surface area. So what you're doing here, as you go to smaller and smaller cubes, you're increasing the area to volume ratio. Okay? Now, let's cut it again. Same mass, same volume, but now we got another two faces there. And cut it again, and cut it, and keep cutting it, and you just get more and more surface area for the very same volume. So that's going the other way. The area to volume ratio, as you get smaller and smaller, you get bigger and bigger area to volume ratio. So, what depends on area? Okay, let's say we have, anyone like iced tea in the summertime? I bet you sweet tea do it. Oh yes, of course, okay. We're from the South, we like our tea sweet, don't we? Okay. Let's just say iced tea and let it be whatever flavor you want to do. Okay, now, if it's a really hot day and Mama just has brewed that tea and you want to drink it, you want to pick big old cubes of ice in it, or you want crushed ice in it?
Crushed ice.
Why?
The cube gonna melt it and make water. You don't want to drink water.
Oh, but hey, the crushed ice will do it even faster. The thing is, the crushed ice is going to cool that hot tea faster than one big old cube. Even if it's the same volume, because you have more surface area. So the greater the surface area is per unit volume, the more reactive things are. They also use, okay, I was in the Navy. Fortunately, I didn't have to do this much, but in the Army, they called it KP. Anyone know what that stood for? KP. It used to stand for kitchen police, I think, or something like that, okay? In other words, those are the people who had to prepare the foods, okay? The other name for it was keep peeling, because they were the ones having to peel the potatoes for the other people to eat. So that was the joke, to keep peeling, okay? Now, if you had to peel 10 pounds of potatoes, you're going to feed a big crowd. You want those potatoes to be big potatoes or little potatoes? If you had to peel 10 pounds of potatoes. Second? Yes, because they have a smaller surface to volume ratio because they're bigger, okay? So, yeah, give me 10 pounds of big potatoes rather than 10 pounds of, boy, how many potatoes are in 10 pounds of small potatoes? That's a lot of potatoes, that's a lot of peeling, and I don't want to do that. Not if I had to peel every one. So large potatoes are easier to peel than small because you've got a larger surface area to volume ratio the smaller the potatoes are. Now I like to think of it this way. My background was soil science. I grew up on a farm in Georgia, and so when I got to pick what I wanted to do, I wanted to get into soil physics rather than just pure physics. So anyway, I wanted to study the soils. And the largest particle of a soil is a sand particle, okay? Anything larger than that, you're talking about gravel, and that's not soil, that's your roadbed or something. And basically, a sand particle, I don't have 2 dimes, but I have a dime and a penny. That's about 2 millimeters. That's the maximum dimension you would have of the sand particle, okay? About that big. That still hurts in your shoe, that's still pain in the foot or somewhere. Okay, but that's the maximum. Sand does not hold nutrient well, it doesn't hold water well, it doesn't hold anything well because it doesn't have much surface area provided.
That's a semi-conductor.
What's that?
A semi-conductor. A semi-conductor.
Oh, okay, right, okay. Okay, I hadn't thought of that. But yeah, silicon is a semiconductor. Okay, but the next smaller than that is called a silt particle. And by the way, a sand particle, if you rub it between your fingers or in your shoe, you feel the grit, right? You feel the grit. The next smaller is silt. Silt is much smaller. I don't remember exactly what size, but it's much, much smaller. If you rub that between your fingers, it feels like flour, okay? There's no grittiness at all. That's a silt particle. But if you really want the small particles, that's a clay particle. Now, we think of clay as this bulky stuff, but it really isn't. The particles in clay would be, if you take that dime, you have to imagine this, and slice it into 1,000 equal slices, and you can imagine that thickness would be 1 micrometer, because this is a millimeter. that would be a micrometer. Two of those put together, 2 micrometers, 2 microns, that would be the maximum dimension of a clay particle. That is small. They get smaller than that. So that's the difference. In clay particles, boy, do they hold moisture. Do they hold nutrients? Do they hold just about everything? But the bad news is they hold them so tight they don't let the plants get them. Okay? So it's hard for the plants to suck that water away from the clay. It's hard for them to get the nutrients away from the clay. But the plants will fight for it. But the sand particles, they don't hold any at all. You water a plant in sand, it goes right through. The roots grab a bit while it's passing through, and that's all they can do. That's why in the sandy soil, your plants don't dry out really quickly. Okay. But in the clay soil, they'll say around, what you need is humus. That's organic matter that holds the moisture but releases it easily to the plant roots. So that's why you mulch and do that kind of stuff. Okay, but it's all dealing with particle size. Okay. So let's now talk about the density ratio. And as you were saying before, it's the ratio. Now there's 2 densities. There's mass density and volume density, and weight density. We'll talk about weight density later. The book talks mostly about mass density, the ratio of mass per unit volume. Okay? It's an intrinsic property of a material. That's why we use it. You can say, I have so many kilograms of iron or copper or whatever you want to talk about. Well, that says something. Or I have so many cubic feet of iron or copper or whatever, or cubic inches or whatever. But that doesn't tell you much. But if you say I have 8.62 or whatever it happens to be as a density, I know you're talking about copper because that, well, I'm making up a number. That is the property of copper. You can have a kilogram of copper or a microgram of copper. It'll all have the same density. The mass per unit volume is going to be the same. And it'll be different from iron and different from aluminum and different from every other material. Okay? It's an intrinsic property independent of the quantity. Okay? It's a characteristic of that given material. Now, the SI system uses mass and volume, so you'll use that when you're dealing with SI. When you're dealing with the English or U.S. customary system, they don't use mass. So you have to use weight density down there. Pounds per square inch, cubic inch, pounds per cubic foot, or something like that. That's a weight density. The weight per unit volume, not the mass per unit volume. Okay? Now, here we're going to jump into something that we're going to talk about later, but we're going to hit it right now. This is the formula that says exactly what we did there. Now, what symbol do they use for density? This book and many others uses the Greek letter rho. Why? I don't know, except they probably use D for so many other things. They don't want to use it, so they use that for rho. Density.
That's a P?
No, it's not a P, it's a rho. A P has a little serif on it. This does not. That is a rho.
I see it now.
Mass per unit volume. Now, mass is usually lowercase m. Volume is capital V. Why do you reckon that's true? Well, in physics, there's another thing that starts with V that we use a whole lot. That's velocity. Velocity is small v. Volume is capital V. You would just have so many things we measure and so few letters to represent them. So we use capital V for volume, small v for velocity. We're not using velocities now, so this is mass per unit volume. That's called rho. This, by the way, is a formula. That's an equation. There's an equal sign that makes it an equation. And a formula is something that's true for any material you might have.
That's the formula for weight density?
For the mass density.
Mass
Mass density, because that's mass on top.
Okay.
If you were talking about weight, then you'll use a different symbol. You wouldn't use M.
Okay.
Now, this leads to another thing. These are symbols representing what I call parameters, quantities that you measure. Mass, volume, density. You use the symbol rho, M, and V. Don't confuse this with a unit. The symbol M following the number, that means so many meters. Okay? So we use the same symbol for a to represent a quantity like mass, that's the symbol little m. But if you're using it with a number like 7m, then you know immediately you're talking about 7 meters, not 7 masses. I mean, yeah, because that would be a unit. So we overuse our letters like crazy, but we've got to because there's so many words that start with these letters. Okay. So that's a density ratio. Ratio of mass per unit volume.
15 minutes.
Second?
15 minutes.
Oh, you're kidding. Oh, to go. Okay. Actually, okay. Now, here's a couple of examples. 4 examples, in fact. I wish I had a cubic centimeter of gold. Okay? Doesn't sound like a lot, but boy, that's very valuable. Gold is very dense, though. 19.3 grams per cubic centimeter. Now here, that's not a SI measurement. If you're doing SI, you would have to use kilograms per cubic meter. Boy, give me a cubic meter of gold anytime, you know. That would be this doorknob. Yeah. Oh boy, dream on. Oh, he's coming back. Good. All right. Let's just say that's a meter, approximately doorknob to floor. That's about another meter, the width of that door. And then you come out about this far, that would be about another meter out. If you had that much gold, I'm retired. Okay, I'm out of here. Okay, that's very valuable. So let's not use, I wish we could, but we'll use the smaller units, grams per cubic centimeter. That would be cubic centimeter being about thickness, length, and width of your little finger, those little bitty cubes of sugar. And don't sweeten anything. So this would be that, 19.3 grams. Iron, you think of that as pretty dense, but look at that. It's less than half the density of gold. So that would be 7.9 grams per cubic centimeter. Water, remember how they first defined what a gram was? They took a cubic centimeter and said that much water weighs a gram. So that's exactly 1.0 grams per cubic centimeter. That would be pure water at a standard temperature and pressure. But air, take a cubic centimeter of air. Does that weigh anything? Yes, air has weight. Not much, but it does have weight. That would be 0.0013 grams per cubic centimeter. That would be less than just a little bit more than a milligram per cubic centimeter. A milligram is really, really, really small. Okay. So the greater the density, that means the more mass for the same volume. Okay. So those are just examples of that. Each of these are supposed to be equal cubic centimeters. Somehow iron looks smaller to me, but it's probably just the color. I don't know. Okay. All right. Does that make sense? Okay. Now, I don't want to, sometimes I get carried away and forget. We haven't hit our first. No, we are. Right now, we're there. Our first example in the book. And I want to, if we can, do most of the examples. Okay? For those who have left, no, there's 2 here that were in the first class. We seldom did an example. We looked at them, read them some, because we needed the stuff in the front part of the book. And by the way, I should have said this back when I was going over the other things. If you notice, this is Physical Science 112, and the other one was Physical Science 111. And most of you are taking 112 without having taken 111, so you don't even know what 111 is about, right? 111 was astronomy, geology, earth sciences, weather, ocean, water, all that kind of stuff. Huh?
Like the climate?
Climate and weather and climate, all those things were under Physical Science 1. Physical Science 2 is this math and physics. But if you'll notice the book, okay, the book, go to the table of contents, somewhere here, and they'll say physics is the first subtopic, chemistry is the second, then you get astronomy, then you get earth science. What? Well, we're in Alabama. Alabama puts this as your first physical science, and they put this as Physical Science 2. because they say this is easier, this is harder, I guess. But guess what? In order to understand this, you needed to know this. So most physical science books put physics and chemistry first, then astronomy and earth science, because all your measurements, everything you measure here, you needed to have this first. And for those who took physical science for the first mini-term, I'd say the examples, well, this is depending on stuff you should have worked, that you would have had if you had had the first part of the book. Because, huh?
Took it in high school.
Yeah, and you probably took it in high school too. And maybe this you took in high school, but we're giving you college credit for it. Okay. All right. And that's what we're going to the articulation meeting about. I don't know. All right, so let's do the examples. We will do the examples in this course. Okay? 2 blocks are on a table. Now, I don't draw very good tables, so this is bottom of page 9, first column. It goes to the top of the second column. Okay, so here we have a table. And like I say, I don't draw very good tables. There's a leg back there. And we have 2 blocks on the table. And boy, if my tables are bad, my blocks are even worse. Okay? Okay, something like that is 1 block. And let's see. And the other block is a bigger block. Oops, something like that. 2 blocks on the table. Really ugly blocks, by the way. Okay. Block A has a volume, so we'll call this the volume of A of 30.0 cubic centimeters. Cubic centimeters, length times length times length, that's to be a volume. That makes sense. Okay. And a mass, so the mass of A, that's little m sub A, is 81.0 grams. Okay, time out. Why didn't they just write 30? Why did they put 30.0? Why didn't they just write 81 rather than 81? Say again?
Because all of them decimals.
Okay, because we're saying this is a very precise measurement. Measured to the nearest tenth of a centimeter, not to the nearest centimeter. So this is a measure of precision. This says you have 3 digits precision. Now when you're doing multiplying and dividing, you keep the number of digits that are significant. Not the units or anything, the number of digits. So that's what they said about block A. Block B, on the other hand, has a volume. So the volume of B is 50 cubic centimeters, 50.0 cubic centimeters. And the mass of B is 135 grams. Now, I don't see a decimal after that. And another digit. You don't need one. This is 3 significant digits. That's 3 significant digits. That's 3. That's 3. Okay? So all these are 3 significant digits. If you had a 0.0, that would be 4 significant digits. We don't have that kind of precision. These are all fairly equally precise. Okay? Now, that's what the givens are. Which block has the greater density? How are you going to do that?
They both is the same.
Hey, you're already figuring, aren't you? Rho for A, the density for A is mass of A per unit volume of A. And what did you find that to be?
0.30.
No. Mass per unit volume. You put the mass on top, 81.0 grams, divided by, that's why you use your formula, 30.0 cubic centimeters. And what would that be? Anyone got a calculator to do the math? 81 divided by 30? 2.70. If you have 3 digits here, 3 digits there, you need 3 digits there. 2.70 grams per cubic centimeters. Always put your units. And notice units are your friends. The grams here and centimeters here, you're dividing the numbers, you divide the units, and you put grams per cubic centimeter, which is a great unit for density. Doing it the way you did, which I think you reversed it, you would have had cubic centimeters per gram. That's not a density, okay? If you don't have your units, you may be making a $6 billion mistake. No. Okay? Let's do the same for B. Rho for B would be what? What's the formula for density? M for B, mass of B, divided by volume of B. And it comes out the same thing, 2.70. That would be, what was it, 135 grams divided by 50 cubic centimeters. Keep your units, okay? And that would come out 2.70 because you have 3 digits everywhere, grams per cubic centimeters. A great density measurement. That's cubic centimeters. I can't write. Okay? Guess what? They're the same density. Now, what we didn't do, and I wish we had, so let's take a moment here. Let's go to the table that's in your book, table 1.3, and look at some common densities of some fairly common materials. That's aluminum. You got it. That block, both of those were probably aluminum. Copper, second, is if you go to the top of page 9, first column, table 1.3, densities of the common substances. Aluminum 2.70, bingo, bingo. Oh, we can't say that in Alabama. Okay. Copper 8.96 grams per cubic centimeter. Iron 7.87. Did you know copper was denser than iron? Yep, it is. Lead, look at lead, man. 11.4 grams per cubic centimeter.
Lead 11.4, and that's supposed to be like the lowest.
No,
That's like a pencil lead, right?
Huh?
Pencil?
No. That we call that lead. Pencil lead is graphite mixed with kaolinite. That's just something to write with. Oh. Lead is that really heavy stuff that they use to weigh down things, like anchors in boats and things like that. Oh, okay. Really, really dense material. All right. Water, of course, is 1.00. In fact, you can say 1.0000 as many as you wanted to. That's the definition, grams per cubic centimeter. Mercury, look, seawater is next. 1.03 grams. It's slightly denser than water. Why? Because it has salt dissolved in it, and salt is denser than water. Okay? So that's why, have you ever been, sure you've been in a swimming pool, right? Mm-hmm. And you probably swim okay. When you went to the ocean, did you notice you float better? Because salt water is more dense than fresh water. Salt water is more dense than fresh water. So, mercury, there's a liquid itself, 13.6 grams per cubic centimeter. That means if you put lead in mercury, it floats. Or iron, or copper, aluminum, any of those will float like crazy in mercury. Don't mess around with mercury, though. It's not a good thing. Gasoline, less dense than water, 0.680. That's why when you have a gas spill on thing, you get a sheen on top because it's less dense. Like the oil spill in the Gulf. That was a mess. Okay. Oh my goodness. We've gone and done it. Okay? So next time we'll start with example 1.2.
Next time we'll do a lab now?
Yeah, we'll probably finish the chapter, I think, fairly easily next time. We only have, I'd say we got over halfway through the chapter tonight, and we have more time next time than we did tonight. Well, we may not have come through, but came close. But anyway, I think we'll finish the chapter within an hour and a half, 2.5 hours. Probably get started on chapter 2 as well. And then at 3:45, when we stop to have a little break or something, we'll go on and go to a lab, probably down the hall here if it's available, and do the lab there. All right. And I'll try to have that run off and ready for us on Tuesday. Good deal. Y'all are very brave and understanding and patient and kind to sit through all this and listen to that much yakking. But really appreciate your
Why is the class so long like this?
Why is what?
Like this class so long.
Well, because it's a mini term, and it has both a class and a lab with it, and that really adds up. So we have a 2.5-hour class, that's 1 week of class, and a 2-hour lab, 1 week of lab, twice a week, because it's a mini term class. Okay. So
That's all
yeah.
they had, or like this whole semester they just had mini term.
What's that?
I said that's all they had for the
Physical
for my
science.
class.
And the reason is because the automotive students have to have things on mini terms.
Okay.
And
do you teach physics?
I do sometimes, but most of the time Dr. Bryant teaches physics. Do you need physics?
Yeah, I do.
Well, then why are you
For
in physical
genetic
science?
studies.
Huh?
I'm going for my major.
What is your major?
I'm doing automated manufacturing right now, and
Right.
then I'm taking genetic studies too.
Oh, wow.
For the,
All right. Good deal. Thank you.
I'm going to turn that in soon. Genetic studies
That's
for my
interesting.
Birmingham. So I'm
Yeah.
going to do my bachelor's degree, and then I'm going to have a degree. Because when I did, like, I talked to my advisor, and then I wanted to do the robots. So if I do the robots, it was not going to be about the theory. It was about the theory about the robots. It was not going to be about the theory. I had to go back to school and get another degree to get into the program.
Uh-huh.
So now I'm just going to automotive
Right.
manufacturing to get me a job and go to work.
Exactly.
Because I want some with it when I graduate
Right,
and just
exactly.
have the degree.
Right.
So I'm going to get this degree and then I'm going to go back to my genetic.
Right.
I just need physics and Cal too, and then I can graduate
Wow.
too with my genetics.
Wow. Yeah.
Yeah, I've been doing that about 2 years,
Yeah.
and then now I'm gonna finish this up because I'm doing the basics, and now I'm just doing a program, and then after this I'm gonna go back to my genetics.
Wow.
But I still gonna do my bachelor degree in Alabama.
Right. Are you going to finish your associates here in both of them?
Mm-hmm.
Both in that and here. So
Yes, sir.
you'll be having me in some of the math courses later too.
Yes,
Yeah.
of course. That's what I'm focused on now.
Sometime in summertime, I'll be teaching some physics classes because we have so many students.
I want you to teach
Transition.
me because you're a good teacher, and I'm not used to those teachers for the physics. So like Cal 1 was a little struggle, but I got the hang of it at the last minute to pass my exam. That's the test. I passed it. Passed the calculus, but at the same time, there was just so much formulas and stuff
Right.
for calculus. But I had Miss Martin though.
Uh-huh.
And she was like advanced. Like she
Right.
wanted it, you had to know it real
Right.
quick to get into a class. And then I had Jurassic about 3 times for my 09. I took 098 for Miss Lewis. That was my advisor, and Jurassic for 101.
12.
Yeah. And then that's when I took calculus. with Miss
Oh, you
Martin.
didn't do 113?
Yeah, with Jurassic.
Oh, Jurassic too.
And then calculus 125 with Miss Martin.
Yeah.
So
And you still need 126?
Mm-hmm.
Yeah.
And
Well, I
then-
usually teach it.
Okay, good.
Now, at night, sometimes Dr. Bryant teaches or someone else does, but in the day, I teach.
Yeah, I just need physics, the 2 physics, and then I just need calculus too, and that's
Do you
it.
need the trig-based physics or your calculus-based physics?
You talking about calculus?
No, okay. The physics, we
Physics
teach
is
both
213.
trig-based and we do, 213? Okay.
213.
That's calculus-based. So you can take it now because you've already had Cal 1.
Right.
Yeah, okay. Now, in the summertime, there's an outside chance I might teach one of those courses,
Okay.
but Dr. Bryant is our usual physics teacher because most of the time we have to stack them, and there's not enough classes for both of us. But when
Okay.
in the summertime, we get a lot of transient
Yeah, I'm
students.
trying to
in.
get in your class for
Yeah.
physics because I'm in your class and I'm doing physics. I already know all this mess right here because I took high school. I know it familiar of the math because I took calculus, so that's gonna be easy for me. But at the same time, I do want to take physics and get my genetic studies out the way because that's when I started. It was genetics.
Right.
So I do want to do robots too, the programming, design, and all that stuff. So I'm in this program now about the automotive manufacturing.
Right.
So that's going good. I like it so far.
Good.
So I'm going to finish that up.
Right.
And because I'm doing blueprint,
Right.
and then I'm doing all that mess, DC and all that stuff, and then I'm going to do some classes to finish the program out some more. Because I'm going to graduate in December. But I might not going to make it December because I'm going to go back and get my genetics.
Right.
I can do December for this program, but not my genetics.
Right.
I still,
It'll take a little bit longer. Yeah.
yeah.
Where'd you go to high school?
Minor.
Minor. Oh,
Yeah,
okay. Good.
minor high in
Yeah.
Forest, yeah. I live in Forest, 30 minutes. My auntie live in Bessemer. She just moved from Bessemer over there, 20 minutes from that First Baptist Church, Carver Church, by McDonald's and that Sheriff Ron over there. Just like 20 minutes away. But now she live in McCullough, by Publix and all that stuff over there now. So I just go over there sometimes, because I be over here a lot of times now, because I was in Birmingham, now in Bessemer, so that's like 30 minutes away from me.
Right.
So I'm used to Birmingham for real, but like all my stuff is, like, I had to go back to get my pay stub and all that stuff, because it's in that system there in Bessemer. So I can't get my books already, because I'm paying out of pocket, because my financial aid paid for my tuition.
Right. I see.
Doing that so far. So I gotta go, and then 2 weeks I got a part-time job doing leads, advertisements.
Oh, I see.
So I do the mail for 2 weeks, and I'm off 2 weeks.
Yeah. Oh.
So that's like a monthly job. But I get tired of that, because that's assembly line. And that be work like 10 hours. But I'm doing that just for getting money in my pocket.
Right.
Because I don't depend on my parents.
Right.
So yeah, I'm gonna do that for right now. But I really want to go to the Honda plant though, to be a technician.
Oh yeah. Okay.
But I do want to further my education, so I might go to Toyota or somewhere to depend on my education.
Right.
And staying there just for the job. So yeah, I got big plans though.
All right. Good deal. Shoot for them.
All right, but I like your teaching though.
Okay.
So just go to Blackboard and get the YouTube videos and all that stuff.
Yeah. Now they're not ready yet.
Okay.
I'll try to get that up to speed maybe over the weekend, but it may be Monday.
I'm gonna check it accurate day, because all my classes in Blackboard, so I really have to check my classes.
Right.
But when you put it up, just
I'll let you know.
let me know.
Okay, we'll do.
Thank you.